Okay, so if you're watching this video, you're either interested in building the D1 or possibly you took the leap and purchased the plans already and you're going to build a D1. This video's purpose is going to be to serve both as a brief introduction to the model and tell you just a little bit about it, let you know if you're maybe interested in building it, and then beyond that it's going to serve as the instructional or the build video on how to put it together. So you need to know right out of the gate there will not be a written instruction manual. This video will be the only form of instructions that you get. I think the video is going to be sufficient. I think after watching it, if you're a builder who's maybe got a couple builds under their belt, you should find that it's no problem at all. There aren't any crazy techniques or any wild approaches here. You don't have to do any machining aside from a little bit of sawing of a couple of one threaded rod and one 6mm rod that you'll have to be able to hacksaw and file the end of. But beyond that, no real cutting of metal or machining is going to be required, and like I said, nothing very outlandish. But just please know, unlike some builders who make some pretty terrific 100+ page build manuals, I will not be doing that, and you need to be comfortable with that. And hopefully after watching this video you'll know if that's something you're willing to take on or not. Before we start the video, I just wanted this little brief introduction where I get to show you just a little bit about the model, talk about it just a little bit, highlight some of its features. I won't really show it operating here. I've got other videos elsewhere that show that, but just wanted to touch base on some of the features of the dozer. So it is 1/14 scale, and it is a very accurate 1/14 scale. In fact, I drew the bulldozer fully normal size and then scaled it to 1/14, so things are in fact very accurate. Because of that, it's quite small. It is as it should be as far as size, but it is a tiny little dozer for a remote control machine. I've packed just about everything I possibly can into it, including a working 6-way blade, which I'm pretty proud of. There aren't many dozers this size or even close to this size that have that working, and I'm also really happy with the fact, or want to brag about the fact, I guess, that there aren't any exposed actuators. There aren't any real mechanical parts outside of the body of the dozer. So these cylinders are actually just dummies. These are some remote control car shock absorbers that have had the springs taken out of them, so they're really just dummies. They look like cylinders and take the place of where the cylinders would be on the real one, but all the actual actuation happens inside the machine, and I'll show you that here in just a moment. We'll take the hood off. This particular model that's on front of me in the bench, I've spent many hours working on the paint job, so very happy with how it came out. Lots and lots of hours of sanding and prepping, and then some of the parts are resin printed, in fact, and it's all been painted with automotive base coat clear coat that accurately matches the Centennial gray. So just know that this one has had quite a bit of time put into it as far as body work and prep work. The one that we're about to build on the video is going to be the opposite end of the spectrum. It's going to be painted steel chassis, which I'll show you here momentarily, and then the entirety of the parts will be printed in the color that they're printed in, so there won't be any paint required on the build that we're going to do today. You'll get a chance to see what that yellow one looks like by the time we get to the end of this video, however long that may take us. So let's just dive in, show you a couple features of the bulldozer. First of all, the cab does come off. It's held on with magnets. I have allowed for some wiring here for the lights that are up front. We'll see that when we get to the wiring part of the build, but the cab does come off. And then the hood as well also comes off. So the hood and grille remain together, and those come off as one unit. You can see that it's hollow inside and has some magnets which are attracted to the edges of the steel chassis here. We'll set that aside so we can take a look inside. 2 actuators, so really it's a pretty simple build. Unless you want the lights to be controlled by your remote, you really only need 4 channels, a 5th if you want the lights to be controllable. 1 for each track drive motor. There's a brushed planetary motor driving each track, and then there are 2 actuators here and a servo up front. Now, I'm sorry, I've misspoken already. There's 5 channels required, 6th if you're going to opt for the lights. So we've got 1, 2, 3, 4, The fifth is the servo for the 6-way blade, and then the sixth channel would be the lights. So that will be your requirements as far as a radio. You do need a radio that allows you to do mixing, track mixing, and I think pretty much nearly every modern computer radio, the $50 FlySky i6S, perfectly capable of mixing those two tracks quite nicely. You only need one channel of mixing. Everything else is on its own channel, so you just need to be able to set up one mix on whichever radio system you select. We've got two actuators here. This actuator, which is on this carriage driven by another actuator, is the one that controls the angle of the blade side to side. And then this actuator, which goes back underneath the electronics here and mounts to the chassis, controls the overall lift of the blade up and down. And then our servo handles our tilt on our blade, so it is able to articulate the blade side to side too, to get you that full 6-way motion on the blade. As I just mentioned, the electronics are all housed in the cab area here. So this is a FlySky receiver. You may have other receivers, but this big 10-channel receiver fits in here quite nicely. There is a power switch here, which allows you to turn everything on and off. This will run well over an hour on this little 2200 milliamp 2-cell that I have spec'd out. That's included in the parts list. Fits in here quite nicely. Because of the fact that it'll run over an hour, I really like to have things on their own power switch, because you may only want to play for 15 minutes, lift the cab off, shut it off, set it aside, and this will avoid you having to plug and unplug and fight with the battery so many times. So I think that's a nice little add-on there. There is room over here for your electronic speed controls. I've provided room in the middle for some Wagos, which I kind of use as a junction block, if you will. So I've got a positive set and a negative set. So we come from the battery to those with our plus and our minus, and then everything goes from there. The power for the speed controllers all branch off of that set of Wagos. Underneath that are the two planetary motors down in the chassis, and that's really all that's in here. There's nothing else hiding. There's really nothing else to see. Everything that makes it move is pretty much visible in this one shot, aside from the two motors, which are hiding. So let's look just briefly, two distinct ways you can build it. The first one, and the way that I would definitely recommend, the way that I intended it to be built, is on this laser cut and welded steel chassis. So Tim at Bedrock RC in Colorado here in the United States is all set up to laser cut and weld these and ship them to you. He can ship them in the United States. If you're anywhere in the US, he can ship them to you, $125, UPS included. He'll get them to your door. It will be as you see it. You'll need to paint it whatever color to approximate the filament that you're going to use. But beyond that, it will be all welded together. It will have the holes tapped. There's several M3 holes that are tapped. That will avoid you having the hassle of needing to tap through this 6mm thick steel. But if you feel like that's something you want to do, I think he can also offer it slightly cheaper if you're wanting to take on the tapping operations yourself. But I'd really recommend you just pay the $125 and get it from him. If you're international, he will send them anywhere in the world. He can do that via UPS. Obviously, that's going to be at your cost. So if it's, and I'm just guessing here, if it's $50 to have one sent to France, you're going to need to pay the $50. He'll just charge you whatever it's going to cost him. The really nice thing about this chassis, first of all, it's stiff. Obviously, it's a great foundation. It's literally built like a tank. It's unbelievably heavy. 2 pounds 13 ounces, as you see it here. For my metric friends, basically 1,300 grams. And so it adds a really nice amount of weight to the model. The other option that I need to touch on is there is a file included to make this one 3D print. So this entire weldment that you see here can actually be printed as one piece. It prints pretty well, actually. But even printed solid, it's not going to weigh but not even a quarter of what this weighs. And so really recommend this, simply because there's not a lot of extra room in here to add steel weights. I've added just a few adhesive weights here along the back wall to get the weight up a little bit more, but there's just not much room inside the dozer aside from all the components that move. So this is just a really great way to get that weight down low. It's got all the strength for everything to mount, and the 3D printed one is plenty strong too. It's a small, lightweight machine. Strength isn't the issue, but the weight and the mass that this gives you down low is really nice. And then he will include a laser cut blade edge as well, so you'll be able to just glue that on to your 3D printed blade. There'll be a file to print this too if you don't want to buy the laser cut kit, and if you're wanting to make it a 100% printed model, you'll be able to print this blade edge as well, but otherwise you'd just be able to adhere that to your printed blade. So that's all there is to the chassis. We'll see more of that when we get to actually building it here. As I mentioned, there's really no machining required. You do need to be able to do some very simple cutting. You've got this 6mm D-shaped shaft, which you'll need to be able to cut off. It comes quite a bit longer. You'll have to be able to saw this off, dress the end up with a file. That's probably the most complicated operation as far as needing to cut or modify anything. There's also a little bit of threaded rod here that needs to be cut as well. Pretty simple. Should be well within any model builder's skills. The finished model, as you see it with the steel chassis, is over 5 pounds, so it's got some really nice weight to it, and it's able to push, I think, a pretty scale amount of dirt. I'm really happy with how it does in the dirt and how it performs. Having said that, it's not a big machine. It's not a big, massive, heavy D10 that weighs 60 pounds. Obviously, in real life, you wouldn't be using it to move mountains like that, and the same is going to hold true for the modeling world. It is a finishing machine. It's a finishing or final grading machine. A lot of uses even in landscaping and the very final preparation of a site. So it's definitely not something that should be considered a mountain mover. That's not what it's meant for, but it's a very maneuverable, agile little thing. And with the 6-way blade, it really allows you to sculpt and add some finished contours to things. It's actually pretty relaxing just to drive it around for an hour and see how flat you can make a given area. It does a nice job of back dragging, particularly with that metal edge on it. It leaves a really nice finish when you back drag, and just happy with how it does, but you just need to know that it is, of course, not a big, massive machine. If it's your only bulldozer, don't expect that it's going to keep the rest of your fleet of machines busy. You've probably got other big machines for that anyhow, but it's a finesse machine or a finishing machine, so just keep that in mind. The rest of the video is going to be the build. We're going to go over kind of step by step. It's somewhat modular. We'll be able to build each track frame and attach them. We'll start with the chassis. We'll build the blade components and then attach them to the chassis. That's really a pretty straightforward build. I think once you have all the parts printed and all of your parts acquired, you should be able to build it in a couple of evenings. If I've figured out how to do the editing here, I'll kind of insert a photo that shows the parts all printed out. There's under 100 parts all total, even with all the little pieces. Pretty straightforward. And then all of the parts that I have spec'd out are available on Amazon in the US. If you're crafty, creative, and patient, and you're willing to get them from AliExpress or another source, they're going to be cheaper. If you're willing to wait, you can probably find most of these components a little bit less expensively. Having said that, the total cost to build it, including 2 batteries that I've spec'd out, minus your receiver, whichever receiver you use, should be right at $500 with the metal chassis. So I think it's a fairly affordable build. If you are a good scrounger, if you've got a good source of a good stockpile, I should say, of M3 hardware, your cost is going to be even lower. I've spec'd out some bolt kits in the order list or in the bill of materials. You're going to be left over with hundreds and hundreds and hundreds of M3 screws by the time all is said and done if you buy those kits, and you may not need to buy them if you have several builds under your belt and you've got a good stockpile of screws. You might already have most of what you need. There are roughly 100 screws in the track, so you probably need to order a pack of those M3x16, but again, those are called out in the bill of materials as well. I do make extensive use throughout the build of reaming. The way that I design things and the way that I size holes is that I intend most of them to be reamed if they have a bolt going through them. We'll talk about that step by step as we go. Everything that's going to just directly thread with a bolt should be sized accordingly, and your screw should go right into it. But any holes that the bolt needs to go through or pass through, or any places where there's pivots, specifically in the tracks, and we'll talk about that when we look at the tracks, but going to make extensive use of these reamers. If you don't already have a set of metric reamers, I think these are around $20. I have them spec'd out in the bill of materials. Highly recommend you get these. So much better than drill bits. They just leave a nice round hole. They'll last forever in PLA or PETG prints. You probably won't ever wear them out in a lifetime if they don't see metal. Great little set, easy to get on Amazon. Highly recommend that you add those to your arsenal if you don't have them or something comparable to them already. All right, I think that that's enough as far as an overview goes, and with that we'll get started here. I think we'll start off with the tracks. Okay, tracks. Let's talk about tracks. You could either choose to build these at the very beginning of your build. You could build them at the end. They're really one of the last things you need to put on the model, so you don't need to make them until the end, but it might be kind of nice to tackle them up front just because there's a lot of repetition here. Very simple process, but lots and lots of repetition to join all of these together. We've got 44 per side, so about 88 of them. Print yourself a few extras, of course, obviously, but we'll go through the process here. So basically, in order to come up with a track like this, ready to put on the dozer, 44 links together here. You can see these are rusty, but you may very well choose to print them in yellow, or maybe you're going to build a gray or a white or some other colored dozer, so you may choose to print these track pads whichever color you want. These happen to be made with the Protopasta PLA that you can then chemically rust with some vinegar, salt, and hydrogen peroxide. So if that's something you choose to do, I think it makes for a really nice look, but it's a little bit of extra work and extra expense, extra complication. So if you just want yellow tracks anyhow, it's just as well that you make yellow tracks. Not a lot of tools needed really here to build a set of tracks. You're going to need enough M3 by 16 bolts, so about 90 of those, 88 of those. You'll probably drop a couple like I do, so you're going to need about 90 by a pack of 100 of those. 2mm Allen driver, drill set up with the 3mm reamer. We've already talked about the fact that I make extensive use of the reamer throughout this build, so hopefully you've bought yourself a set of those. 3mm drill bit would work, but the reamer just does a much nicer job. And then print yourself out a few of these jigs that are included. I think that 3 of them is the perfect number. As you get to going, it just seems to be the right number for me as I build these tracks, but you may only print 1 and just do each step over and over. I think it's easier to do each step like 3 times together. The gluing, the placing, it just seems to work well, but maybe 3 works for you, maybe 4 or 5, maybe only 1. You'll need enough of the cleats here, so obviously print yourself around 90 of those. Again, you'll probably drop a few. They're not super fragile, but you might break a couple as well. And then enough of the pads. You're going to need all of these printed in the color of your choosing, or if you're going to paint it, maybe it doesn't matter what color they are, but I would still print them in a color close to the paint that you're going to go for. You're also going to need super glue of choice. I won't tell you what glue to buy. Medium thickness works well for this process. You could get away with thinner or thicker, just depending on your tolerance. Love this Bob Smith glue that you can get here in the States at Hobbytown, but and on Amazon. There's lots of other good brands as well. I use this particular accelerator for a couple of reasons. This activator comes in a small can, which is easy to work with, and also it seems to have very little effect on PLA. Doesn't kind of cause the ghosting and the white chalky discoloring that some of the other brands that are a little more aggressive can cause. You don't have to have accelerator, but it will definitely make this process go a lot quicker. And since there is so much repetition, I think you'll find it very helpful. I'm just going to build a couple here and we'll glue them together, and then I'll kind of show you the idea of what's going on. The cleats have got a flat side, which you've printed down on your printer, and then it's got this side with this raised curved bar that's actually gripped by the drive sprockets. You're going to want those facing up throughout this entire process. So, I'm sorry, facing down. Told you wrong right off the bat. Facing down. You'll have this smooth side up. This is where we're going to do all of our gluing. So, curved bars are going to go down. So it's really just a matter of snapping these in the jig. You'll see it fits in there. It's not too tight, but not too loose. It just kind of drops right in there. So we'll just do a couple of these. Hopefully my glue is open and flowing here. we will just apply a little bit of glue to the backside. Doesn't have to be a ton. You want to get full coverage, but you don't want a whole bunch of extra that's going to ooze out either. And having your lighting ideal for this is best. I've got lighting set up for filming here. Turns out it's not the best for gluing. I line up all of my track pads like this, and then I just take my activator and go right down the middle of them, since that's where the glue is going to land. We want the bar towards us, thin edge of the track forward, and we're going to put it into this guide, kind of tip it in there so that the front corners are touching. That way you've got it aligned and square. And then I just snap this down and make sure that I'm giving some forward push. As long as it's nice and square in this jig, it's going to be nice and square on the track cleats, and you're not going to end up with tracks that are all wonky and messed up. If you get one of these wrong, you'll definitely know it, because when you do assemble your tracks, you'll have one that's off and it's visually very apparent. You'll know it right away. You'll have to swap it out. Not that it's a big deal, but so if you've used the accelerator, you can take this out of the jig within just a couple of seconds. And this is where that, for me, 3 comes in perfect. I do 3 of them at a time, kind of set them aside, give them a few seconds, and then pop all 3 of them out of the jig in groups of 3, and I just work my way through the process over and over and over. Once you've got 44 of them, we're ready to actually assemble these. We're ready to put them together, and that's where the reamer is going to come in handy. I like to have these button-headed bolt heads hiding to the inside of the machine, so that all you see is this black dot on the outside. Therefore, I build my tracks 2 different ways, and the cleats are set up for that. They're universal. They don't have an allowance for left or right, just to keep things simpler. Since these holes really need to be reamed for super smooth motion anyhow, I find it just makes the most sense to do them afterwards. So here's where our reamer is going to come in handy. We're going to ream all of the small holes, or the narrow side of the cleat, I should say. So these narrow, not the wider side. And then on the wider side, we're only going to ream 1 of them. And this is going to be different from left to right. You're going to want to make 44 of them one way and 44 of them another way. And that will allow you to have those bolt heads hidden. If you need to, take just a little bit of emery paper and clean these up. You can see the reamer doesn't leave too much junk. A little blow and you can generally get those cleaned out. And now you're going to need a whole bunch of your screws. A whole bunch of your M3x16 screws. Should slide right through, because we've reamed this hole, and this hole. And then the third hole should be printed just the right size to allow you to thread this in and bottom it out. Now, when you do this, you don't want to get too crazy, because if you get too crazy, you're going to strip this hole out. Having said that, they're so easy to make that if you ruin a couple of them, big deal. They should fit together nicely like this. You can see that those glued together good, they're lined up, and when we stack a whole series of these up, they should line up nicely and fit well. If you've got a goofy one, like I said, you'll know it, because you'll have a misaligned track pad and it'll be crazy and wonky. Just go ahead and replace that one. This should move very freely. You can see these have been ran a little bit, so it's maybe not super fair, but they should be very free. This is a used track, and like I say, that definitely helps wear it in, but should be super free. There should be no binding, no jumping, no kinking. This should move really nicely. If it doesn't, take a little bit of time to make sure that you don't have any debris in here from the reaming, that you don't have a bunch of elephant's foot somewhere from your printing that's causing problems, but kind of made these with the right tolerance, so that as long as your printer's well tuned in and well set up, which it needs to be for the rest of the build anyhow, or any good model, but as long as you've got that set up, these should all fit together quite nicely, and you shouldn't really have any of that binding or catching. If you do, figure it out now. Take the time. If you've got one that just plain doesn't cooperate with you, take it out and throw it away. Big deal. Hopefully you've printed a few more. If not, go print a few more. And these should all just move, like I said, super, super nice. So that's really it to the tracks. Not a complicated process, just one that requires quite a bit of repetition, quite a bit of the same step over and over. I've built a few hundred of these now, so it's probably pretty easy for me, and I think by the time you get to the end of building 88 of them, or however many few extras you make, you're going to be really good at it too. If you are doing the weathered tracks, I would make and weather a few extra track pads. You know, print yourself over 100 of them. If you're going to do that, just because these weather a little bit differently every time. I've made probably 5 sets of weathered tracks on different machines, and they all look just a little bit different. So make yourself some spares up front. Although the variation, you know, is nice. You like to see variation within the track. That's part of what kind of makes it look so cool. But I think it'd be helpful whether you're doing the body color or the rusty to make yourself a bunch of extras. These don't really they don't really seem to break. In my hours and hours of driving, I've only, I think, broken 1 or 2 ever. It takes like, you know, a minute to change one out, so not a big deal. But make yourself some extras, have them with you, so that if you do suck a rock into the tracks or something and pop one, break one of these little ears, you'll be able to swap it out in a few seconds. Take 2 bolts out, put the new track in. Super easy, no big deal. So that's really it for building the tracks. We'll move on to the next step. All right, let's get started and do some building here. We'll get started on the chassis. Hopefully you just watched the part of the video with the tracks and maybe tackled those and got those set aside in a pile, hopefully ready for later on. We'll get started with the chassis now. At the same time, we're also going to work on a couple of the parts related to the blade, but it, I think, makes more sense to talk about them now, so we'll work on those and then set them aside. Some pretty basic tools really for these couple operations we're going to do here in this little clip. 3mm reamer, as promised. We're going to make extensive use of the 3mm reamer. We're going to need a 2 and a 2.5mm hex driver. If you don't have a set like these, please get them. Get something. 15 bucks you can get set on Amazon. Don't use Allen wrenches, for goodness sakes. It's just tiring, but you knew that already because you're smart. Pretty basic stuff here. We're going to need a couple of bearings. These are 10 by 6 by 3. We're going to need 2 of those, so we're going to insert 2 of those into the side of the blade pivot here. They should go part way in by hand and then either squeeze them in a vise, or if you have a nice set of like parallel jaw Nipex pliers or something like that, they'll squeeze right in there without too much trouble. So we'll just get those set in there. There is a front and a back on this. I've actually labeled it here so that I don't mess it up during the video, but this side is longer. That goes towards the front. The side in the back has a bigger notch or a bigger cutout. The reason for that is it's going to allow this to swing down into it, specifically the part with the screws here. We'll talk about that in a minute, but we want to make sure that we orient this with that bigger relief towards the back. We're going to screw it down here. We need 6. These are M3 by 6s, button heads. It's important to use button heads here, mostly in the back, just for clearance, so that we don't have any issues there. I have reamed out these holes ahead of time, so these 6 holes here have all been reamed out with the 3mm reamer. Just makes it easier for these button-headed screws to pass through. Get these all thrown in there real quick. That hole's got a little bit of paint in it, I can feel, definitely. Good idea to run a tap through these holes after you've painted, if you're smart. This one hole's actually fighting me here. Off camera, I will run a tap through this hole, but you get the idea. We will start with a new screw here, and we'll put in 5 of the 6. You'll get the idea. We'll put the 6th one in later. Okay, let's set our reamer and our bearing aside here. This front block that goes underneath the grill has a pass-through in it here that's going to allow the servo wires to go out to our blade tilt servo later on. So we'll leave the top of that notch up. On the bottom side here, I've tapped both of these M3, and that just makes it a little bit easier. We'll use some M3 by 8 button heads here. and we will come from underneath with 2 of those. Get that attached. While I do this, let me talk about these magnets that you can see in the top of the block here. So those are 3mm by 2mm magnets that are inserted into those printed bores in the top of the spacer block. It's not so much important that you orient them in any particular way. Later on when we do the grill, it's going to be important that you orient the magnets that go into the grill in the opposite direction. But what I'd just caution you or advise you against is make sure that these are both oriented the same, so that they're the same, north and south. The polarity of the magnet is the same, and that'll just make things a little bit easier later on, because you'll be able to follow the same convention for all of your magnets that are going to go in the hood. The ones along the side of the hood don't matter so much because they're actually going to attach to the steel frame here, unless you've done a printed frame, in which case you'll be inserting some magnets at a couple locations here. But just important to pay attention to those. You don't want to get all done and go to set your hood down and find out that the grill is repelling itself away from you. That wouldn't be cool. Let's look at this cross beam next. I have reamed these holes through the middle. You can still see a little bit of debris here from reaming, but these are set up for regular socket headed cap screws, 3x10, so we're going to need 4 of those. Now when we mount this to the model, you'll see these L notches. We're going to put that L towards the front of the chassis, because ultimately later on in steps that we do later, there are going to be bolts that come through these holes and attach to the track side frames, and you want to be able to access that from the front of the model. And also the track frames wouldn't fit because they have a corresponding ear that's going to go in here. So we're going to make sure that we get that notch towards the front. These are also reamed M3. That way later on when we do attach those track side frames, these bolts will just slide right through with no resistance. So we're going to get this screwed to the bottom of the chassis here. We'll flip it over. Again, M3x10 for these. She should just screw right down. The nice thing about having these laser cut holes in the chassis is that everything should just really line up quite nicely. Modern fiber lasers are so accurate that things are just spot on. It's pretty remarkable, actually. Certainly, if you're a Loctite kind of person, you could put a little dab of maybe removable blue Loctite on them. This isn't a model that vibrates or shakes a lot. I don't think you're going to have any real need for Loctite, but if it makes you feel better, certainly that is an option. I like to just get these a nice amount of snug. I'm kind of walking it back and forth here, not deforming or smashing the plastic, but making sure they're all tight. They should be basically flush with the top of the print when we're done. And inside we should have no real bolt thread sticking up. That's important because it's going to need to clear this part, which just barely misses the floor of the dozer here. So for now, we're going to set the chassis aside. Let's talk about a couple of blade pieces here. We'll come back to this in a later step. We'll put some motors in it, attach some more things to it, but I'm going to break things down into kind of baby chunks here. So we'll look at these next. So this is the pivot, the eccentric arm that one actuator imparts force on and that the other actuator rides on. We'll see that later on. Here we have some M6 shaft collars. I've removed the short little set screws that come with them, thrown those, set those aside for later on as a spare, and I've replaced them with M3x6. We'll need a 1.5mm driver also for these. So this is just an M3x6 set screw that has gone through the plastic housing and has gone into the corresponding hole in the shaft collar. It's handy when you are setting these up. My mark here is faded from me touching it, but I actually put a mark on these shaft collars before I press them in. That way I can press them part way in, I can look at that mark, I can grab it with some smooth job pliers, and I can get it aligned with this hole. It's also helpful if you have the hole open, so that as you're pressing it in, you can see and you can verify in that hole that your set screw is going to land and go home without any real binding. So just a matter of repeating that on both sides. The way that this part is designed, it's super easy to put this in a vise and squeeze it, or a big pair of parallel jaw pliers and just squeeze those in. They're a nice tight fit, but nothing that should deform or stress your print too much. They should just squeeze right in. And then the blade arm is very much the same. So we've got again an M3x6 set screw here in each side, and shaft collars just squeezed in and squeezed in. So ultimately, the way that this is going to work, I'm going to grab the shaft here if I can find it, is that we're going to have a 6mm D-shaped shaft. If you look at the end of it there, it's got a flat on it. And this is going to slide through our pair of shaft collars that are on our pivot here. And they're also going to slide through the blade, and they're going to ride on these bearings that the blade pivots up and down on. So assembling it's not too tricky. We'll do it later, but I'm just giving you an idea here. It's going to slide through one. You have to imagine the bearings are in here right now. If this was in the chassis, it'd slide all the way through. Important here to have all your set screws backed off, obviously. This would all be centered bearing, and these ears on the chassis would be right in here. And then you'll be able to pivot the whole thing down and tighten up these 4 set screws, and that's going to lock everything together on this D shaft so that when the actuator moves this arm, it will be moving the whole U-shaped blade arm up and down. And again, we'll cover that more later, but just a little bit of detail as far as what's going on there. Okay, that's going to do it for this step. We'll have another jump cut here, and we'll move on to the next step. Okay, the next thing we're going to make is a track frame. So the idea is we'll end up with one of these with the motor in it, all built, ready to go. There's a lot of, it looks like a lot of parts here, but it goes together pretty simply. It's really not too bad at all. Just need a few basic tools, 1.5, 2, and 2.5mm hex drivers. This is a tool I haven't talked about yet. It does come in handy if you don't have one. You can use an X-Acto blade instead, but this little plastic specific deburring tool is really nice. You can take the edges off where you might have some elephant's foot at the base of your prints. Some of these parts like this, which fits very, very closely around this hub connector, it's important that you not have that there, because if you've got that elephant's foot, it's going to hold it out, make your sprocket run untrue. So just kind of a handy little tool if you don't have one. You can also use an X-Acto blade. Just clean that edge of that elephant's foot off if you can, so that it'll fit that hub better. Let's talk a little bit about some of the parts I've got laid out here, and then we'll get into the actual assembly. Obviously, sprocket's pretty self-explanatory. This is the hub that's going to attach to the motor. We'll do that in a little bit. A cover, planetary cover in real life, but here it's just for show. Some spacers and some bottom rollers. I've already built the rollers. Looks like I've lost one of them because I should have 6 of them here and I only have 5. We'll fix that somehow here in the editing. Basically, you're just pressing an 8x3x4 bearing into a little 3D printed sleeve. The bearing is just slightly wider than the sleeve. That's okay. Just press the bearing flush on one side. Then we've got a dozen of these spacers. We've got the front idler wheel. It is 2 pieces that are glued together. Make sure you align them really well when you glue them together. And then the bearings will align nicely on this 3mm set screw. It's a 3x16 set screw. The bearings are the same 8x3x4 bearings. They're the same in all of this. Same here too, another 8x3x4 on the back side of this top idler. Little cover that we'll glue on the top idler. We've got a yoke here for the tensioner, a tensioning block, some spring. Let's talk about that real quick. I didn't spec out a spring because I get springs out of assortments that you buy, and those assortments change all the time. It's going to be pretty tolerant. Something slightly heavier than a ballpoint pen spring is going to work well. Anything in the 3 to 5mm diameter range just pushes against the back of this yoke. Has to fit inside the block, which is about 5mm. So I have this 4mm spring that I can just cut off chunks of. So find something similar. If not, like I said, a sturdy ballpoint pen spring should work just fine. We've got the motor here, our 100 RPM planetary gear motor. Stored in the front of it here, I've got two M3x6 button-headed cap screws that we're going to use to hold it into the track frame in a little bit. I've soldered the connection on. Make sure you match up with what goes with your speed controls, but if you use the speed controls that I spec'd out, you'll want to put this female end on the motor. I do also solder up one of the motors with the convention that's marked on the motor, plus and minus, and I do the other one opposite. That's certainly stuff you can fix in the transmitter afterwards, but since you know you're going to have to reverse one of them, since it's a tracked vehicle and one on each side, I just do it ahead of time, but it doesn't really matter. You can fix all of that in the radio now, so solder them on however you want. It's not rocket surgery, no big deal there. We've got the two track frames, inner and outer. Make sure you clean these up really good. Get your support set well so that they peel off pretty good, because it's important that this block be able to sit in here and that this yoke slide. We'll talk about this when we actually put it together, but if that stuff doesn't fit well, you're going to end up having to do a little bit of sanding. So it just pays to have your support strategy kind of set ahead of time so that stuff peels off pretty clean. And if not, you can sand this back face just a little bit. Let's talk about these two pieces, because I did do some hole prep on them. The outer track frame has 6 holes along the bottom, all 6 of which are tapped M3. You can, throughout this build, you can just force screws in these holes and they will cut their own threads. It is definitely possible, but if you tap them, it's just going to be so much nicer. They're gonna engage and not try to spread things apart. It's just better. So run a tap through them real quick if you can. Tapped all 6 of these from the back. It's also important to note on here there are 5 holes that might get obscured depending on how your printer prints on the plate and how it supports. So you want to make sure that all 5 of these holes are cleaned out. They're a 2.5 millimeter hole, and they're ultimately going to accept these little self tappers, which are 14 millimeters long. So we've got 5 of those 3x14 self tappers. They're going to be going into these holes. So that's all the prep work that needs done on this one. Again, make sure it's clean in here in the pocket. The inner half of the side frame is similar. Here we're going to ream through M3 because we want these 3mm by 20mm button-headed screws to just slide through them. So we want to ream all of those so that we'll have an easy time when we go to assemble it. Also going to ream these 5 holes. So these are the holes that these self-tappers, 14mm self-tappers, are going to go through. So make sure that you've got all 5 of those reamed out to 3mm. Also ream out the 2 in here, 3mm. Those are where our M3x6 screws from our motor mount are going to go. And then up top here, we've got one more for the idler wheel. Idler's going to mount on there ultimately, so that's a tapped M3 also. So I think that's all the prep work that we need to do. Let's start throwing some parts in here. The motor is a nice tight fit. It should slide right in there, but it's a fairly tight fit. It definitely goes in with just a little bit of resistance, not a terrible amount, but she slides right in. And then you can clock it. Bear with me here as I try to use the light to my advantage. Like I said earlier, light for filming isn't always the best for working. And these are a couple of screws where some blue Loctite, I would say, is mandatory. A little dab of blue Loctite. It's not a high vibration machine or not something that's going to try to come apart crazy, but this is kind of buried in the machine. Not that it would take you a terrible amount of time to get to it, but it seems silly not to use a little dab of Loctite here where we've got some nice holes in the face of this motor. Just going to be a good way to ensure that those don't come loose and come out into your sprocket and hub and cause you all kinds of problems. Tensioner block here. It is 2 pieces. I just glued them together. You'll see that there's some little tiny screw holes, and there's a corresponding slot in the back here. If you want, you've got a little bit of further adjustment as far as where you can put this, but in practice, in the 2 I've built so far, I really find that it's not necessary to put an anchoring screw in here. I'm going to leave the feature there. It's hidden inside the machine. You don't really see it afterwards, so I don't think it hurts anything, but it's also probably not necessary. I'm running my machines without this block, just sits in here. I wanted to be able to basically add a little bit of extra preload to the spring if necessary, but so far it just hasn't been a problem for me. So we'll drop that in there. We'll put the chamfered kind of rooftop looking side up, and hopefully we get this on the first try. I may have to take this back apart depending on how everything goes together. Like I said, sanding can be critical. It looks like it's going to fit here fine. You should have no gaps here. This stuff should line up pretty good along the top here. See, I've got a tiny little gap, but basically everything just lines right up. So let's start dropping our self-tappers in the back here as I have everything fall apart. Again, M3 by 14, 5 times here. We'll drop those in, and they should all just screw right into those nice 2.5mm holes that are in the outer track frame face. We'll get a couple of them in here, get this started. Yeah, it's okay to drop the yoke in afterwards. That's why I haven't done it yet. But that block definitely does need to be in there. The block that's going to ultimately receive that spring. Make sure everything's lined up kind of nice here, that the two peaks on the trackside frame line up. And again, we're using these self-tappers. If you don't want to buy the set of self-tappers, which I think this is only like a $10 or $12 assortment, but if you don't want to buy it, you could certainly tap those holes on the other side and just use regular socket-headed cap screws here. But these bite so nice into the plastic where we're going through plastic into more plastic. I just prefer these. They really do grab well and give a nice bite. Obviously, don't get them too tight or you'll strip them out. Okay, we are good there. You can see no gaps. Everything's lined up nice. Tiny little gap here. I might actually back a couple of these screws off and tighten them back down again and see if that gains us anything. I've still got a tiny little gap there. I'm not worried about it, but if it's much more than that, you would want to probably sand down the sides of this tensioning block a little bit. It'll still move in there, but it's pretty tight, so that tells me that the sides of that block are interfering just slightly with that pocket, but we'll keep moving here. Let's turn our attention to the underside here. Rollers, pretty straightforward. We're gonna slide a button-headed screw in. Some tweezers would be nice here. We've got a dozen of these spacers. They should print out so that the hole is just slightly over M3, but if not, if these don't slide nicely on a screw, then you might want to run an M3 reamer through them. Then we'll drop a bearing in. I'm going to set all of these with the little bit of extra bearing that's hanging out. I'm going to set that towards the inboard side of everything. I think as long as you're consistent, it doesn't really matter. There's room enough for them to move around. And last but not least, we'll drop one more spacer in, and we'll grab our 2mm driver. These, if I didn't mention it, are M3 by 20s, 6 times down along the bottom here for the rollers. And get it so it's just tight. We don't want to distort or really mess with this track frame. This should roll freely. It should have just a little bit of wobble or a little bit of play to it. And we're just going to repeat that 6 times here. Might do some fast forwarding in the video, but I'll let you watch them all here. The other advantage of having these outer holes reamed is that we're not doing anything to spread or affect that track frame as we're assembling these. Just verifying that they all roll freely. Okay, through the magic of editing here, I'm going to go make one more and I'll be right back. Okay, and just like that, I'm back with the 6th roller. Let's get this last roller dropped in here. Okay, again, all 6 roll nice. All 6 button heads should be down flat along the body. We should just see the ends of the screws out here in the outer track frame, and that part is good. Next, let's turn our attention to the top roller here. Same thing, we've got a, in this case, M3 by, let me measure this so I don't tell you wrong. I believe that it's an M3 by 10, but I want to be sure. So we'll put some calipers on it here. Yes, indeed. M3 by 10 will hold your top roller on here. Looks like a 12 would fit too. There's plenty of meat in this upper roller. And we just want to make sure that we're not so tight as to prevent that from spinning nicely. On the face of it here, we've got a little roller cover. You can choose to either use some tacky glue or something that you might be able to remove later on. In fact, that's not a terrible idea, just because you could get to this if you needed to, but I'm just going to go all in and use some super glue and glue our little faux cover on the front here, just making sure that it is lined up nicely so that it kind of shares the same OD as the roller. Okay, that's the only thing we need glue for, I believe, in this step. Sprocket next. So this flange is going to mount to the motor. The motor obviously has a flat on one side. We're relying on a single 1.5 millimeter driven 3 millimeter thread set screw, so we definitely want to say blue Loctite is mandatory here. This is sufficient to hold it, but if you don't put the blue Loctite, I think you'd be sorry. And we will just slam this all the way home. Because of the way I've designed it, the outer face of the motor should stop this flange. You maybe don't need it like super tight so you don't have metal on metal, but this should slide right up against that brass or bronze bushing that's at the front of the motor, and it should put us just in the right spot here. And get that as tight as you feel comfortable getting that little 1.5 millimeter driven set screw. That's going to be pretty important here. Next, we are going to drop in our 2 sprocket halves. You can see they're divided just slightly asymmetrically, so when you print the 4 of these, make sure that you've got 2 and 2, otherwise they just simply won't go together. But there's definitely 2 distinct halves. It's the same. Everything on this side is symmetrical or the same as the right side, so the left and right are the same. So just pick one of your 2 halves. It doesn't matter which one. I have pre-tapped these M3. Just going to drop them in behind the flange, and I've got 4 M3 by 6 button-headed cap screws here. You can also use there's room in here, so you could use socket-headed cap screws, but I just use button-headed cap screws whenever I can. I just prefer them. So we'll get this started. Again, that same caution I gave you earlier, you saw me doing it while I was talking. Please just ensure that you've got any kind of burrs or elephant foot type stuff cleaned up, so that you don't run into a situation where these parts don't want to line up when you mate the 2 of them together. I'm having a heck of a time here. I'll just grab an M3 tap. I said I tapped them, but I may actually not have. Yeah, it would seem that I did not, because I'm cutting threads right now. So again, this is where you could force that screw in there, but why? It's so much easier to just go ahead and tap it. Such a simple process with PLA. Again, I use PLA for all of this because I'm not worried about being outside on a 120-degree day. If it's too hot for a model, it's too hot for this guy, but you may choose PETG or some other material. That's up to you. PLA is perfectly suitable. You won't have any issues with that, as long as obviously you stay out of the crazy hot weather like I just talked about. Let's just trim the flash off the backside a little bit from the tap coming through. Making a mess on my black mat here that I had all cleaned up. Alright, let's try that again. Let's see if we can't get some screws to go in. It's always harder to do things in front of the camera than it would be if you could just hold this in your lap and do it. Alright, we got one started. It should be all downhill from there. You could use Loctite on these, but since they're going into plastic, I think it's probably of nominal benefit. And I won't get any of these 4 super tight until I've put the other half. Thankfully, with this planetary, we can just spin that right around, and this is a good sanity check for us. Does it go into the slot without hitting? Hopefully yes. That's kind of all baked in and designed into the parts, so there's really not much adjustment. You could shim the motor a little bit if you had to, but it should not come down to that for you. As long as you use the parts I spec'd out, it should all kind of fall right together here with very little adjustment or guesswork. We'll get our 4th and final screw in here, and then I'll walk around all 4 of them, kind of tighten them up just to ensure that that pair of prints stays nice and flat against this aluminum flange. Alright, so we'll get that one tight. Get that one tight. Again, just a reasonable amount of tight, but this isn't a super high torque or high powered machine. It's just a tiny little 380 motor. It's not that powerful. So there we go. Spins nice in the slot. Should run true. You can see it's running nice and straight, no wobble, no crazy problems. If you have problems, correct it now, because certainly it's going to be exacerbated once you put tracks on it if you do have problems. This piece you could glue on, but really I think you'll find that if you line up the bolt heads, it just pretty much snaps on there and should be good. Actually, I need to clean up. I've got some elephant's foot in there that's preventing it from getting all the way down onto the to the printed portion of the sprocket. It made it past the aluminum part, but not onto the printed part. Line those up. Should be able to push it home, and more than likely it's just going to stay on there. Add a couple drops of glue if you want, but I like the fact that you can wiggle and pry it off at least a couple times until the plastic stretches out, so that's up to you. Set that aside for just a moment. Let's turn our attention to the front idler wheel here. We've got a yoke. One side is reamed M3, the other side is tapped M3. Again, an M3 by 16 set screw. We're gonna line our idler wheel up, put our set screw through both bearings and into the threaded side of the yoke. Use our 1.5 millimeter driver here. It might be necessary for you, depending on how exactly 16 millimeters your set screws are. They vary a little bit. If this is sticking out of either side, you're going to need to run it on a sanding block. These stainless set screws I've got are perfect. They're the right length, but I've had some black oxide ones before that must have been like 16.2 millimeters long. At any rate, you need to ensure that it's not sticking out, and even at that we may have to sand this here. We're about to find out. She slides pretty good. Let's drop our spring down in the hole using some tweezers, and I'm going to put the kind of factory end, if you will, of the spring up, just because it's better, I think, if it rides against the back of the tensioner. So we've got that down in the hole. Again, spring, I'm going to kind of leave that up to you guys. Find a spring that suits you, that you like the feel of, and I'm definitely gonna have to sand this a little bit. This should pop out just slightly, and it's not. So let me go over to the sanding block and take just a little bit of meat off of here and see if I can get a better result. Lost our spring. Let's drop that back in there again. And if this doesn't work, I'll just show you on the finished version. Yeah, it's not moving as freely as I would like. It's still got some spring to it, but I'm just going to show you how it works on here. You should have a situation where the tensioner is pulling out against your tracks and it's floating freely. Obviously, if it's binding, it can't do its job. So make sure that you've got that moving nice and free so that you've got some float. After that, it is really just a matter of putting the track around the outside. You can either put it on the toothed portion and kind of walk it around, or it might be simpler to just leave one of the screws out when you assemble it. Bring the two halves together and tighten that screw up, and that's it. We'll set both track sides of track frames aside. I will get this tensioner moving a little bit better. We'll set these aside and they'll be ready to drop into the chassis here in one of the upcoming steps. Okay, we're going to move along with the chassis here and add some detail to it, bring it a little bit further along in the process. Before I do, in that last installment of the last section, I was having some issues with that tensioner sliding smoothly. I did just a little bit of sanding and got that freed up and got that spring mechanism working like it should. So we'll set that aside. We'll need it pretty soon here to attach it to the chassis. But for now, just a few items we're going to need. The main chassis, we've already attached some parts to it. We've got this Back body section, I've already attached the fuel and the hydraulic and the def caps to it, so those are all just glued in. I've tapped these 6 holes underneath M3, so you're going to want to tap those, unless, again, if you're just going to run the screws in, that'll work, but I find tapping a lot easier. We'll need our bottom cover plate here. I've tapped these 4 holes M3. And then we've got our back plate. This actually prints as 2 parts, so we've got the hitch and the back plate. I've already glued the 2 together just so I don't need to do that on camera. Got a couple of printed steps here, the serrated kind of saber-tooth looking steps that we'll glue on each side here. And then as far as hardware, pretty simple. We need an M3x20 and a nut. A lock nut would be great if you have one, but most of the assortments don't have a lock nut, so we're just going to glue this nut on. But if you've got a nylock, that would actually be preferable, but I didn't want to spec one out just for one nut in the whole build. And then we're going to need 6 of these M3x10 button head screws. We're going to need our longer of the 2 actuators. This is the 25 millimeter actuator, the longer of the 2. This is what's going to raise the main arm up and down. We'll go ahead and get that installed in the chassis now. And we've got a printed spacer here. Ream this out to M3. And you may have to ream these ends of the actuators with your 4 millimeter reamer. They're notoriously kind of full of nylon flash in there, and it can be hard to push this delicate little 3D printed part through there without deforming it. So you might just give those a real gentle reaming just to clean that flash out. As far as tools, not much needed this time. Probably some tweezers for this nut, our M2 driver, and a little bit of glue. So here we go. I think we'll attach, honestly, any of these parts you could probably put on in nearly any order for this step, but I think we'll do the actuator first. That's going to be the most finicky part, and so we'll attach that. Let's take our M3x20, put it through this hole in the side, wires facing up on our actuator, and we'll slide the actuator. Again, it's got that printed spacer already installed in it. You could use a nylock here. I think I'm just going to use some clear Loctite, as I refer to it, just a little dab of super glue on the end of the threads here. Ultimately we could get it apart if we needed to, but we sure don't want that coming apart inside the belly of the dozer. Once we've got all the electronics in it, it'd be a real hassle to get to that. So we'll get our driver on the outside here. We'll start our nut. Hopefully I can do this in one try. Nope, of course not. Like I said, it's always harder to do this stuff on camera when you feel like you have an audience watching you. And this is a tiny little nut here. See if we can get her to grab. As far as tightness goes, we're going to just tighten it down on that 3D printed bushing, but we want our actuator to still move very freely. You should have just a little bit of play, a little bit of slop here. Again, wires facing upwards, and with that clear super glue, everything should set up. Clear Loctite, the super glue, everything should set up. If you've got a nylock, go for it. You could even put an M3x25 here with the nylock on it. It's not really going to get in the way of anything. Nothing sits right here, so if you want to do a slightly longer bolt in the nylock, go for it if you've got that in your hardware repository. All right, I think we will flip it over here. This part has a thicker ledge and a thinner ledge. Thinner goes towards the front, thicker towards the back. You'll know you've got it right when you look at it from the side here and your bolt holes actually line up. So if you were to flip this part around, the bolt holes wouldn't line up and this flange would hit this steel cross member. So kind of really only goes one way. We will put in, you know, I've failed to tell you you're going to need 4 bolts for this, so I was a bit of a liar just a few minutes ago. Let's dig out 4 more M8 or M10 bolts. Either one would work. We'll just use M10s so that everything is the same in this step. So it looks like we'll need 10 M10 steps for this bolt, not the 6 that I told you just a couple minutes ago. Sorry about that. And we'll run these in, tighten them down. Do it without scratching anything, hopefully. Okay, we'll turn this around. Get a couple more on this side. You could paint these bolts if you wanted, but honestly you're barely going to see them once the model is together. So certainly if you want to paint your bolts, go for it, but I've tried to keep the bolts on this entire model as hidden as possible, so you're barely going to see these back behind the tracks. You'd have to really look for them. Okay, we've got those on. Next, let's turn our attention to this cab base. We'll just set that on here, and again, just the M10 bolts, so we'll start dropping those in. Get a couple of these started, hopefully. Go ahead and drop our others in here. Six bolts is probably way overkill for this. 4 would have been plenty, but 6 just seemed right at the time. Quick note here while we've got the chassis on its side. You will see a hole here. Don't worry about that hole. It's not needed. It's the sister of the hole on this side, but in order to make the laser cutting and laser welding process simpler and to just eliminate any variables that could be a problem down the line, each side has a hole, so we only have one part and they're symmetrical. So go ahead and ignore that. It's not something that that you need to worry about. It's just an extra hole. Next, let's glue these little side steps on, and they're just going to glue into these laser cut notches here. A little bit of your favorite CA on the back side here. You could, if you wanted to, wait until the very end to glue these on also. Just since they're a little bit delicate, so you could wait if you wanted, but now just seems like a logical time to put them on as far as the assembly, but you'd be able to get to them at the very end. So if you'd like to add it when you're doing your final touches and your detail parts, that would be fine also. And I make the bottom of them flush with the steel, so there's just a slight reveal on the top where you get to see the metal there. It doesn't really matter. They can go anywhere up or down there. And our last piece for this step, we're going to glue our back section on. So it's going to be a little tough maybe to get it here on camera where you can see it all, but basically we're going to put glue here and we're going to glue this piece on. It should line up flush on the bottom. I put the top on first because it makes a real nice stop for it. You can just slide it right up against it. So we'll just put a couple dabs of glue here. If you're gonna try to pull something with the hitch, then definitely put some more glue along the bottom here where the hitch lies. Not that the dozer is gonna have a ton of pulling power, but it could pull a little something. So if you want to use that hitch, make sure that your bottom is good and glued. We'll let that set up. Okay, that gets the chassis a little bit further along, gets us to a good point, and I think the next time you see the chassis, we'll be adding some track frames to the side of it, getting the motors inside and preparing to start dropping in some electronics, preparing to start adding the blade to the front of it. All right, we are going to do a little bit more work on the front blade arm, the front yoke here, and get it a little bit further along, and then we'll get it joined to the chassis. Let's talk about servos for just a second. The little servo that I've spec'd out, the little 4.3 gram servo here. Nice little metal geared unit. In all likelihood, you're going to use yours with the stock wires and then ultimately a servo extension to get it through and up to your receiver. I went just a little bit above and beyond on the one I'm going to install here, and I actually disassembled this servo and I soldered in some 3-conductor 32 gauge silicone wire that's going to be long enough to make it back to my receiver. So basically I made an additional pigtail. I can't really expect you to do that at nearly 50 years old. My eyes certainly aren't good enough to do it unassisted. I've got this sweet microscope here that I solder underneath and a little jig that I hold the servo in, and soldering these little 32 gauge wires can be a bit of a trick. So in all likelihood, you're just going to use a servo extension. I wanted these to look more like hydraulic hoses rather than some colored servo wire. You could also probably put a piece of heat shrink over this or paint them black. I know that paint will stick to the vinyl real well over time, but you only see a little bit of it here between the yoke and the chassis where it goes under the grill, but just that little extra touch. It doesn't mean you have to do it. Certainly it's completely optional. If you do solder it on, by all means, please test this thoroughly with the servo tester. Make sure it's good. You're about to glue it in the yoke, and once you do, there's no getting it back. Also, before you take it off of the servo tester, whether you're using the stock wiring or the modified wiring, have your servo centered and put this included arm on the servo, and then carefully attach this 3D printed arm. I've just got mine held in with a pin that is glued, so a little pin, let's measure it here. I'm pretty sure that it is 1.5 millimeters. Yep. 1.2 millimeters. So just some fine brass or steel wire, whatever you've got. Get it so that this part moves freely. And then I left it stick up extra on top. You really won't see it, and that way I was able to apply a dab of glue around it. It's going to sit in the model like this. I've also prepared the wires underneath by bringing it out of the servo opening underneath the servo and just putting a tack of glue to hold it. You can do that same thing with these stock wires. In fact, it'll stick better to the stock wire since it's not silicone. Glue that down so that you can submarine this in, and everything will be in this channel right here. This channel will allow those wires room. Before we put the servo in, tap this M4, tap this M3. M3 tap only the outer faces. The inners are 2.5, and you'll see later that some pins are going to go into them, so we don't need to we do not need to tap those. Tap and tap M3 and M3 out here. Again, an M4 tap here, keep in mind this is at an angle. The hole runs parallel with this face that you can see that's angled, and it is a blind hole. On the back side there's just a very thin 3D printed wall. So we are going to run this in until we start to distort that back wall and bow it out just a little bit, and then you'll know you're at the right depth. It can be handy here as this gets a little tighter to put a driver through this, make it a little bit easier to crank this down. And I'm watching back in here. I've already ran this one in and out off camera, so I've already bowed this back wall out, but I'm just watching to see when I start to deform that back wall, and that's when we're in. Got just a couple threads showing here still. Hopefully you can see that. Just a couple threads showing, and then make sure that we orient this so that it's nice and straight with the frame. The Heim joint ball will do all the rest of the work, but we want to have this nice and straight. So looking at it from the side, you should have it in there at an angle. As far as the rest of the hardware we need for this step, we really only need one M4x12. I believe it's the only M4 bolt in this whole build. I might be wrong later on. We might run into one more, but we're going to need that. The piece of shafting that we already cut. We already talked about this earlier, so I may not have called out a length earlier. About 71 millimeters. There's some tolerance here. Millimeter either way is not going to matter because it sits in these collars and these frames, but basically 71 millimeters for your D-shaped shaft should be just right. And let's get this put together. So servo, again, centered because if you don't have it centered now, you're not going to be able to get to this screw to center your servo horn. So make sure you have this centered, set up nice and straight before you insert it. As you can see here, it pretty quickly gets obscured, and there's going to be no getting to that after the fact. The servo should sit in here so that the back corners of it are just flush with this reinforcement tree that comes up. Again, there's some tolerance here too, but should be just flush with that. So we're going to slide it back a little ways. I'm going to put just a little bit of my favorite super glue down in this groove, and then we're going to slide the servo into it, let the servo sit in that. It does not take a tremendous amount of glue here, just along the bottom is fine. You could put a little bit on the side, but again, it's a 4-gram servo. It's not doing a ton of work as it tilts the blade, and it certainly doesn't have to be glued in here any kind of crazy way, but it is pretty permanent once you've glued it in here. I've tried to take them out. The dissolved super glue also unfortunately affects the ABS case of the servo, so there's not much saving it. Once you've glued it in here, it's in here. A little shot of accelerator. Again, I mentioned it earlier, I like this brand because it doesn't seem to mess with PLA, at least the PLAs that I use. All right, we've got that done. We'll put this off to the side. It is ready to go. Our servo's nice and centered. Our Heim joint is in. The rest of the hardware we installed in previous steps, so let's bring it over and get it married up with the chassis here. We're going to drop this down. D-shaped shaft. It's got a flat on it. Keep in mind that flat is going to go basically towards the back of the bulldozer. It's going to line up with all the hardware, and the holes in the side of the plastic printed part here are going to help you with that, because they do in fact have that D shape incorporated into them as well. Like always, it's a matter of holding your mouth just right as you get everything lined up here. I wasn't quite low enough. See if we can get this through our bearing. Let's get our actuator flipped up and out of the way. Should be able to slide this through the chassis. Again, all of this stuff just fits, so it's going to be a little bit tight getting it through. I might even try coming in from the other direction. I don't know. Figure out what's going on here. I think I know what's going on. I've had this in and out a couple times, and I have tightened the set screws down on it a couple times, and I think I've probably added a few burrs and boogers to it in the process. So I'm going to give this a real quick emery swipe here. Hopefully make it a little more inclined to slide through the bearings here. The bearings are the tightest part. I now know exactly what I've done. I failed to do a step earlier that involves reaming the plastic. So I'm making it through the bearing, but I'm hitting the plastic. So we'll fix that here in real time. A little bit of a snafu, but we'll take care of it. And I'm going to make myself a note here off camera to actually increase the clearance on these holes, so that when you build this, it's not something you'll even have to worry about. You won't have to ream these holes. I'll get them opened up for you, but you'll get to see one of my mistakes in real time here. There's no reshooting this since we just glued the servo in. That's it. We've committed. Yeah, you can see there's just a little bit of interference there, so the metal shaft makes it through the bearing, doesn't clear the plastic. So let's just pop our bearings out. Shaft is a handy tool for that. Let's grab ourselves 6mm reamer here, just out of your view so I don't get a bunch of chunks on my black surface. I'll ream these out. Again, I'll make myself a note so that this isn't an issue for you. I seem to have lost a bearing somehow. There she is, rolled all the way across the bench. Let's get those back in. Love these parallel jaw pliers for stuff like this. They're a nice parallel squeeze. We'll get those seated once again. Let's just make sure our shaft goes through here. Look at that. Like butter. Good deal. Okay, we will once again respect our front and rear. Again, bigger gap towards the rear to allow this this horn to fit. And let's get this screwed back in. We'll try this again. Who knows, maybe I'll edit this part out and you'll never even know I messed up, but maybe I'll leave it in. We all need a little reminder once in a while of our mistakes. Maybe I'll leave this in here. Get this a little more centered under the camera for you here. Okay, we'll just check to make sure that all 6 of these are nice and tight. They're going to get a little bit difficult to get to here after this next step. Okay, I'm happy with that. Let's try this again. Try to get this centered under the camera, make it so you can see. Again, flat towards the back. Look at that, she slides right in. Okay, now at this point, we need to insert our eccentric arm here. It's going to be a tight fit, should slide right down in there. And again, more things to line up. There we go. It's amazing how stuff lines up once you have the holes reamed. Okay, get this rod centered. If you cut it to 71, it should be just about flush with the ends. At this point, make sure that this moves freely, that nothing's binding. We're about to tighten everything down, so ideally it would be moving very freely at this point. Bring our delicate little servo wire up here so I don't pinch it. All right, that looks good. I'm happy with that. I'm happy with how everything is centered where we're sitting here. So let's go ahead and swing this down as far as we can, and we'll bring our, actually it might be easier to swing it this way. We'll bring our 1.5, trying to get it so you could see it here, sorry, hope you can. Bring our 1.5 millimeter hex driver in, tighten up that side. You'll find as you're doing this, this is a heavy thing. We're 3 pounds here, so we've got a heavy little thing to not mess up. Get those nice and tight, and we'll swing our actuator up out of the way. Should be able to get us straight. You don't need a ball driver for this part. Hopefully get your straight hex driver in here. All that prep work we did getting these inserts, these collars inserted in these parts in one of the very first steps is paying off now. Get those nice and tight. You could certainly use blue Loctite on these if you want to. It wouldn't hurt. What we're looking for here is tightness. So there shouldn't be slop and play. It's going to be difficult to show on camera, but this arm and this eccentric that the actuator is going to mount in should be basically locked together, so that any movement here is going to be translated to movement of the blade up and down. If we have slop and slack here, you're going to have slop and slack in your mechanism as you try to move your blade up and down, and you don't want that. So now is the time to make sure that all 4 of those set screws are nice and tight. Everything seems good. This is moving with very little pressure, super smooth up and down. We've got a good range of motion here, so yours should match that. Bring in a bolt here, M4 by 12. We're going to swing this actuator down. I, off camera, got my actuator pretty much where I wanted it. A 9-volt battery can be really helpful here. I've even soldered on so that I can plug into motors that have got the connector on them, but can be really handy here to orient this actuator pretty much where you want it. We'll put our M4 bolt through there, take our 2.5 millimeter hex driver, and run this thing home into the 3D print. Doesn't have to be super tight. I didn't do it just now, but I'm going to go back and put some super glue on the end of that screw so that it stays put. We don't want that backing out and jamming into the steel chassis here. So you should have a rigid assembly. Basically, the only backlash here that we should have is the little bit that the screwdriver in the actuator has. There's no eliminating that, but you can see the blade is pretty tight. We will get this wire through here. I've already put the end on mine, which was a bit of a mistake. It's going to not need to be on there in order to go through this little opening. So we will take care of that off camera. We'll get that through this opening so that it comes into the chassis, and then ultimately we'll route it up and over this clamp and back to our receiver. All right, that is it for this step. I think in the next installment here, we're going to get the track frames installed on either side. Now that we've got the majority of the blade arm installed and out of the way, we might add some cylinders here. I'll see which step seems the most logical next. Okay, we're going to prepare to mount the dummy hydraulic cylinders on the outside of the dozer here. As I had mentioned earlier in one of the previous segments, these are some RC crawler shock absorbers that have had all of the guts removed from them, so that they're basically just dummy, completely free-moving cylinders. I've already modified these two. I'm going to show you real quick how to modify these two, and we'll mount all 4 of them up on the dozer. You can set the springs aside. There's some nice 5mm or 6mm diameter springs that you can use for a future project. Go ahead and unscrew the clevis end, unscrew the cap, slide it off. Pay careful attention to this T-shaped nylon bushing. Slide, or rather unscrew the back cap and its ball joint. We're going to dump out the spring and set that aside. That's a spare. Now move the shaft back and forth a couple times and you'll be able to move all this packing stuff up. 2 orange silicone O-rings, nylon spacer in between those 2 O-rings. We're going to get rid of those. So we've got kind of a hat-shaped bushing facing down, then a regular bushing, then we'll put this other hat-shaped bushing, the larger of the 2, back on. We'll slide the cap over and we'll screw that back together, and you should have a very free moving piston. Screw the rod joint back on the end of it, and last we'll screw the cap back on the cylinder. It's as easy as that. Set these 2 nice little silicone O-rings aside, put those in your spares if you're someone like me who saves absolutely everything. Alright, let's get rid of the spring out of this last one, and then we'll have all 4 of them ready to mount. Set our black spring aside, unscrew our cap, unscrew our rod joint, we'll slide that cap off. We'll move this back and forth a few times. We'll be able to get our packing out again, same as before. So this time the hat-shaped nylon piece actually stayed in the cap, and that's fine. Just looking to get both O-rings out of there. We don't need the sliding resistance of the seals that those provided, so we'll just get rid of them. Back together. Screw our tail cap back on here, and pull the rod out. Screw the rod joint on it. Okay, so we've got 4 very free moving cylinders. We should have all of those ready to go. They're all 4 the same length, so they're interchangeable. As far as other items that we need 2 M3 by 16 button-headed cap screws. We need these 2 small spacers that are part of the parts in the blade package, I believe. And then we've got our 4 axle set screws here, our 4 axle bolts. These are kind of neat. M3 head on the top, and then M2 shaft. So those are a really nice nice way to make these cylinders pivot. So let's have at it here. Pick any of the cylinders, like you say, they're the same. Put an M3 through it. Slide our bushing on. A little bit of Loctite here on the end would probably be a good idea. Let me grab some of that right now. I wasn't quite prepared with that. Get a little bit of blue Loctite at the ready here. If you wear contacts like me, these containers make super handy dispensers for both paint and things, glue and things like this. Alright, we'll get a little dab on there. Of course I made a mess of that naturally. Get a little dab on there. And then there's 2 threaded holes on either side of the chassis here that we can get this started in, hopefully. Again, like I've said several times now, everything's easier when you're not trying to show it off. I'll run that down. Doesn't have to be crazy tight or anything, just so it holds it flush. We'll bring this back up, turn our rod in sideways, and we'll grab one of our axle bolts and we'll put these through, axle set screws. Real common on drive shafts on your semis and things like that. You've probably used them before. If you're into 1/14 scale, they make a nice pivot in this case because they're flush and don't stick out and bother us at all. We'll get this other cylinder on here. Get our spacer. Grab a little dab of blue Loctite. And we'll get this screwed down. Again, no reason for these to be particularly tight on the side of the dozer here. They've just got to hold the cylinder. Alright, let's get this stuff out of the way so we can tip this back up within frame here. Okay. You could put a little bit of Loctite on the heads of these bolts if you wanted to. In fact, on these next 2 for the lower 2 cylinders, I will do just that. And we're just going to prepare our other 2 cylinders here. Put a little bit of Loctite on that threaded portion. We'll drop these in, again silver shafts facing forward just like the other pair. Run those in. Give this a quick little wipe so we don't have blue Loctite on the yellow outside, and then we'll be free to pivot this and we'll attach it to the blade later on, but for now we'll just leave it kind of hanging out here in the wind. The silicone mat is nice for filming, stuff shows up well, but it's not the easiest to pick things up off of sometimes. Okay, and once again we'll clean up our Loctite. Off camera here, after I hit pause, I'll go ahead and put some Loctite on those other 2 just so we know that they're locked in. We'll set those all aside. We're ready to attach the blade now at this point after we've got the tracks on and some electronics inside of it. That was a short, easy step. Next we'll move on. I think looking ahead here, next we'll probably mount up some track frames on either side, so that'll be our next big step. Okay, let's attach some track side frames to our main dozer chassis here. Pretty simple step. It seems like a big step. We're adding some major components together, but really there's only 8 screws here and a couple tools needed, so really pretty simple. You'll need the main chassis completed up through this point, obviously. Each of the 2 side frames that we've built already, you want to make sure there's no tracks on them, so if you've had tracks on those to kind of play with them get them running smooth. You want to take those off at this point. We won't be able to get the Allen drivers in there if not. 2.5mm hex driver. It is super helpful on this step if you have a 2.5mm ball driver, because these back screws, back 4, are going to be a little bit tricky to get to. The front ones come from the front. Pretty straightforward with the driver to get in there, but a ball driver is really great for these back ones. You could also do it with a ball-ended Allen wrench if that's all you've got, since it's only 4 screws. Not a huge deal. Quick note about our motors. I don't know if I touched on it well enough earlier. Make sure that your tabs that you solder onto are bent down and laying fairly flat. Obviously make sure they're not shorted to the motor case, but you want to have those laying pretty flat, because there's not a ton of room in between these when the two come together and the terminals do line up. So there's a gap, and you'll be able to see a gap, and we'll verify that after we have them installed. But you don't want those sticking straight out with a bunch of wire and solder globs on there, because if you do, you're going to run into problems with them shorting together in the middle. So that's about it. We'll have at it here. Let's pick up one of the frames. Looks like this is the right side. Feed your wires through. Again, you might have different wires on here depending on your speed control. These were chosen because they'll work with the little combo 2-in-1 ESC that we're going to use in this build that I've spec'd out, but you might have picked a slightly different version, I realize. All right, we're going to slide this right in. And getting that back notch lined up is going to be critical here. We want that to be nice and lined up inside of our 3D print here. So this steel piece needs to slide nicely inside of that frame. We'll take our ball driver and one of our 3x10 self tappers. Again, you could use regular screws here if you wanted to and tap the receiving holes, but I like these self tappers for some of these parts that are going to mount metal to plastic or go through one big thick plastic into another. You've just got a nice grab to them. Put one in. Should be able to come from the bottom is probably the easier approach for this second screw. Let me try to turn this so you can see. We're just running that screw in the bottom hole. Might even be able to use the regular driver for this. Let's see. Yeah, probably use the regular driver for this one, but the ball makes it a little bit nicer. You just don't have to tear up the head on that screw as we run it in. And then we're going to do 2 more in the front here. In the previous step, before we ever mounted this cross beam, we reamed these to M3, but make sure you've done that if you haven't. Definitely going to want to have kind of a slip fit through the front piece, and these screws will grab on the back piece. That's actually part of the track side frame. Alright, there's one done. Let's do the other side. Let's get our motor wire up and out of the way here. This step in particular is one of the reasons I had mentioned earlier on that you might want to wait to glue these on, even though we did it in an earlier step. This step is proof of that, definitely, because I'm needing to show some pretty good care here so that I don't get those, get my hands. It's so tempting to grab the dozer right there is what I'm trying to say, and you'll end up breaking those off. So maybe another justification for doing those later on, even though I showed it earlier. Each time I build one of these, I learn a little bit of something. It's definitely a bit of an evolution, and I probably should have ordered that a little bit differently, but a little bit of care, you'll be fine. Alright, we'll get these in. No Loctite or anything needed if you're going to use these self-tapping, these sheet metal thread looking coarse thread. They grab and tighten down nicely. And we'll get our screws in the front here. You might have to persuade or bow this just a little bit to get it into place. Get those holes to line up nicely. Okay, screws 7 and 8 are in, and let's just pay careful attention here in the back. I'll try to get this right under the camera, maybe even shine some additional light in here. Just gonna want to make sure that we have room, and you can see back here I've got a gap and I have a gap, so the gap isn't huge. Make sure that after you're soldering with these terminals you don't have anything touching. If you wanted to, you could slip a little tiny piece of clear plastic or something down in here just as an added insulator. Just don't have it stick up above the motor cans, because you'll see in the upcoming step battery tray is going to drop in here and it sits nearly on top of the motor cans, so just don't have anything stick up that would interfere. We'll just lay these wires down for now. We're going to use those coming up when we add a speed control, but there it is. Side frames are mounted. Okay, it's time to start on everybody's favorite part, wiring. We're gonna do some work here to get the power switch and the XT60 panel mount wired up so that we can get this little sub-assembly dropped in the dozer. I've done a little bit of the work off camera here that I'm just gonna go ahead and explain. I didn't feel like I would be able to film myself trying to solder these, and I don't think it's of great benefit to you, but XT60 panel mount, get that mounted in your printed housing here. Yours might be black, yours might be yellow, mine just happened to be black. They come with some little M2.5 screws that take a 1.5 millimeter hex driver, so get that mounted up. We're going to come from the positive terminal of the XT60, which is of course the square side of an XT60, and we're going to bring a wire up to one side of our switch. It really doesn't matter which side, but I find it easier to do it on the front side here. And then from the switch we're going to come out with that positive, and we're going to run our wiring through these holes, through this hole in the fin, and we're going to bring it out the side here. I've just used some 16 gauge silicone wire. It's probably overkill. 14, even 18 is probably big enough, but I had the 16, so I used it. It is black and red, but they were a pair that was together, and I peeled them apart, so you might see some flashes of red there. Don't let that confuse you. And then negative, we're coming off the negative side of the XT60 with our black wire, and we're just going to come right out of the housing here, out of the side, and we're going to mount that to a Wago here momentarily. Please just double, triple, quadruple check. I'm super paranoid about this. Once in my life ever, I wired up an XT60 wrong, and when I plugged in the battery, everything blew up. So don't do that. Look at the markings on here. Even get a battery as a sanity check and hold it up there and make sure that your red and blacks line up. It's super easy to mess that up, so please be really diligent about that when you solder those up. Throw some heat shrink on there if you want. It's not necessary. This is all going to be hidden out of the way where nothing can really touch it, but I feel like if it's worth doing, it's worth putting some heat shrink on. On your housing here, drill these 3 holes, M3, or tap, I'm sorry. Tap's not the right word either. Ream. We'll try this again. Ream these 3 holes, M3. We're going to be putting some M3 socket-headed cap screws through them, and then sand your bottom. You'll see I've sanded mine just a little bit here. That's going to sit on the steel deck of the dozer here when we install it, so there's going to be some artifacts left over from the from your support structure. You want that to sit nice and flat, so give that a little sand as well. I do everything with these Wago plugs. Obviously you may choose to wire things up differently. These are in the parts description and I've spec'd them out. You're free to do your own thing, obviously. Build your dozer however you want, but I think these are a really slick way to have a terminal board of sorts here incorporated into the dozer that lets you wire things up in a pretty neat fashion. I like to designate one for plus and one for minus. Obviously, if you're familiar with these, you already know this, but if not, all 5 of these are interconnected in the back by a bus bar. So anything you connect to one terminal is connected to all of them. So I think of this as a bus in the case of this model, and I like to have a negative bus and a positive bus when I build a model. So I take a little Sharpie here and color the face of these 5 paddles black, and then I take a red Sharpie if you've got one. If not, you could just let the orange designate your positive bus, but I take red and color in the face of these 6 paddles. 5 paddles, sorry. There, now when they're side by side, they're in the model and you're jamming wires in and out of them, it's going to be pretty apparent which one's plus and which one's minus, so you don't have any mistakes. We're going to take our glue. Again, just choose your favorite super glue. Okay, sorry for the edit or the cut there. The alarm went off and it was time to go to volleyball practice and pick up kiddos. Back to where we were. Got the red and the black. I like to put the red towards the back on here, but it really doesn't matter. You can do whichever you want. Just put some super glue directly on the back of the Wago. Don't need a ton, and I like to put it so that it's just flush with this wall and slide it all the way back against this back wall. Give that a couple seconds to set. We'll do our black one. The wall doesn't extend out quite the whole length, so we'll get glue on about 4/5 of it here. Small little dab of accelerator there. Okay, and then I bring the black wire underneath, and I'm going to put it in this first terminal position towards the front of the strip. So I'm just going to gauge for myself how long this wire needs to be, and then cut it off. These Wagos grip quite a bit of wire. You want to strip off about a 1/2 inch, 12-13 millimeters worth. It'll get a really good bite on a nice sized piece of wire. So we will tuck that in. Again, don't let this red on this wire confuse you. It is in fact the black. Okay, got that. And now our red we'll also put in the opposite first terminal. We'll bring that up, cut it about here. You can do a little fine tuning, maybe if your length isn't quite exactly where you want it, as long as you haven't cut it too short. Okay, and sometimes it's helpful to use a little tool in here to flip those up. So now we've got 4 available positions for positive, 4 available positions for negative, and obviously everything will run through the battery. So we'll have the ability to turn everything on and off at once. Let's get some of this junk out of the way and we'll get this screwed in. To mount this in the body, we're going to want to bring the motor leads up. I have labeled these off camera, left and right. That'll just make it a little bit easier during the setup stage. And then I've also got wire for the actuator. I'm going to put my speed controllers out here, and I'm going to put the receiver here. So I'm going to bring the wires up through this outside hole in the floor. We'll just pay attention here that we don't have any of those wires pinched underneath. I'd mentioned before the bottom of the battery tray sits right above the motor, so with my finger I'm just guiding those forward and making sure that they are not pinched between there and the motor. And then use the shortest M3 bolts you can here, screws you can here. These are 5 millimeter. Depending on your assortment, it'll have either 5 or 6 millimeter in your assortment. And we should have 3 spots here that we can secure. And in full disclosure, mine I tapped after the fact, and I actually broke a tap off in one of the holes up here. So mine's going to be held in with 2 screws. Yours should have 3, but 2 is sufficient. But since I have a tap broken off in this hole, I won't be able to use it. So, okay, if you want, at this time, you could stick some weights back here. There's enough room for 1 layer of weights along the back wall. If you want to use these tape steel weights, there's just enough room back here to get 1 layer of those in, so that will allow you to add a little bit of weight. And then depending on your electronics, depending on the size of the speed controls and the receiver that you opt to use, you may have room along this side, and you may have room over here. You definitely have room over here. Be careful again. I used heat shrink, but be careful. So off camera here, I'm going to add a little bit of weight. You could even take this tray in and out a couple times, use it to size things up and determine where exactly you can fit some weights. But you can definitely get another 2, 3, maybe 4 ounces added to this. Add a little bit of weight over the rear wheels here if you're so inclined. And at this point, we'll call that good, and we'll be ready to bring in the rest of our electronics and start filling in. Okay, next we're going to mount up the actuator that will handle the side-to-side angle of the blade, so we'll get this actuator installed. I've already started to route the wire through from underneath because I didn't want to struggle with that on camera, so I'm bringing it up through the hole in the floor. But again, 21mm actuator here. We'll drop that down in the cradle. We've got our top cap, ream these 3 to 3mm. Put our top cap on, and then we've got 3 M3 by 12 self tappers here, and we're going to use those in this pinch block. So just get them started, and then obviously, like anything else, you're tightening down, kind of walk these across so that they're all fairly even. All it has to do is prevent this cylinder from sliding back and forth, and in fact in the future you can use it as a point of some fine adjustment if need be. We'll get that tightened down, make sure our actuator is locked in place, everything is good to go there. Pull the wiring through. This is where I mentioned earlier I've got a 9-volt battery that's got a terminal soldered onto it. It makes it a little bit easier possibly to do some fine positioning of this ahead of time. I want to get this actuator right in the middle of its stroke, and that's where I want to park it because we want the blade obviously to be able to bevel both ways. So what I'm going to do is run it out all the way, and I'm going to make myself a mark. This is all approximate, but it's going to travel approximately from there to there in our use. So I'm just going to put a mark about in the middle, and then I'm just going to drive it back to that point, and that's where we're going to leave it sit, because in an upcoming step we'll be attaching threaded rod and a heim joint to this that's going to run forward to the blade mechanism. But if we just leave it centered pretty much, again, you've got some tolerance here. The actuator will move further than the blade, and in actual practice, I should mention that you need to pay attention. These actuators have limit switches in them, but unfortunately there aren't. Actuators only come in certain increments, and there aren't any that are ideally suited for this design that would allow me to use those internal stops, those internal limit switches. So really these actuators, both in lift and in tilt, will go further than the dozer would like them to go, further than the physical limits. And so most of the time when you're using the blade, you're going to be making manipulations, but I definitely suggest having it on a stick, not on some kind of switch that can be left to one end or the other. You know, as you're driving it, your brain will tell you where it needs to be, and you'll stop without exceeding the limits. But if you put it on a switch of some sort, it could try to go too far one way or the other, eventually burn up an actuator. So just keep that in mind as you're driving it. I'm making it sound harder than it is. In reality, it's quite simple. It's very intuitive once you get to doing it. Let's look ahead just a little bit here. We're not going to put the speed controllers in yet, and in fact, I may even do that on camera and then cut back to it, because that's going to be so specific based on exactly what you choose. I realize a lot of people won't necessarily use the electronics that I spec'd out. The ones I spec'd will fit and will work. Feel free to use your own stuff, but if you are using the 2-in-1 ESCs that I specified, of course you'd have 2 of these. So you've got your power, 1 channel of servo and a BEC, and another channel for your servos, or for your receiver. I'm sorry, I keep saying servo. On the second one of these that you hook up, snip the red wire. We only want BEC coming back from 1 speed control, so we only want that battery eliminator circuitry 5-volt supply coming from 1 speed control. We don't want them competing with one another, so snip one of your reds and keep the other one. And then these, unfortunately, the polarity, if you will, is not the same as the actuators you can buy, so something's going to need changed. Either the speed control needs rewired, or the actuators need new ends spliced into them. Obviously, if you don't want quick connectors, you could just cut everything and splice and solder and heat shrink. That's one option. If you want it to be a little more modular and be able to be disassembled, you're going to need to make a choice in with the set of pigtails that you got that are part of the bill of materials. You can either choose to swap out what's on the speed control so that it will accept the actuator, or change out what's on the actuator so that it will accept the speed control, and it's really up to you. I'm probably going to do the speed control simply because these are way too long. As you can see, they're way longer than they need to be, and space is limited in here. So I think I will just trim back the heat shrink along each side, fold these back so I can expose my solder pads, and then I'm gonna solder these on just nice and short, maybe 30 millimeters long, 1.25 inches long, something like that. And then I'll rely on all of this extra slack to be able to get those hooked up. But basically, we've got 1 ESC for the motors, and the polarity is going to be good because we've put the correct plugs on the motors. So we'll have 1 ESC powering our 2 motors. We'll get that tucked down in here, and then we'll have another ESC tucked in beside it that's going to do our two actuators for the blade tilt and elevation. And then the 5th channel that we'll have coming up will be our front servo that handles our 5 and 6 directions on the blade. I like to put some super glue on here. We'll do that now, and glue this wire down. I think that it's just a nice way to keep it able to move, but yet safely out of the way at the same time. So I just allow a little slack here, lay this down in the glue, and we'll give it a little spritz here, maybe give it a little poke to get it down in that glue. Hopefully I used enough. Let that set up, maybe. Silicone wire obviously doesn't love to stick to super glue, so sometimes you need to bridge across the top of it if you've used silicone wire like I have here, and actually build a little cable clamp of sorts there. And now our 5th channel will be ready to go back to our receiver that we're going to mount in here as well. 2 more parts that I need to add on. These kind of should have been part of the track mounting step earlier, but more or less got forgotten. These caps cover these slots in the side that are necessary to get everything inserted, and so they've got a thin leg and a fatter leg. We're going to glue them with the thin leg towards the back, so pretty simple. Just a couple dabs of super glue here, and we're going to slide that right in on top of our planetary motor housing and just slide it up against the chassis. Make sure you've got it nice and square so that it's straight up and down, and that's just going to glue in there like that. I'll do the other side next. Again, thin leg towards the rear of the dozer. A little bit of glue on there. We'll slide that in, get it squared up, get everything in place, and those will be glued in. Okay, I think in the next edit when we come back, I am in fact going to have the speed controllers both wired in here. I'll have a receiver in place, and I'll have my five channels plugged in. Again, don't know that you need to watch me do every little step and every little wiring of that. Your radio is going to vary from mine. Your speed controls may vary from mine. You may choose to use something else. Just know that the amount of space you have is fairly limited, so you do want to choose some compact speed controls. I'm going to use a very small FreeSky receiver because the person that this dozer is going to has a FreeSky XE, so you're going to see a small little FreeSky receiver here. The larger FlySky 10 channels, I think I've got one here in the drawer. Perhaps I can show you. These larger FlySky receivers, like you get with an i6S, will fit no problem. Realize that's going to probably be a pretty common radio for this. So either the 6-channel, which is this, or the 10-channel will fit in here no problem. You've got room to plug in all of your servo headers. With a receiver like this that's got the 2 longer antennas, the FlySky stuff, I route these antennas out through this side hole and then put them along the side here. There's room for these 2 antennas to go along the side, maybe a little dab of glue or some double-sided tape to hold them in, but you can see you can get your receiver in there. Of course, you'd have the wires through this hole in real life, but you'll be able to mount it with all of your plugs facing upwards. That way you'll be able to access those, see your labels, get to them really easy as you're wiring things up. So again, I think we'll jump ahead here. When I'm back with you, you will get to see this with all the radio gear installed in it, and we will move on from there. Okay, back. Let's take a look at the installed electronics here and talk about those just briefly. I'll look at the radio setup just a little bit. Again, I'm not going to go super in depth with the radio because I realize you're probably using something different than me, but I'll just give you a general overview of what's going on here. I've got both track motors hooked up, obviously both ESCs for both track motors hooked up. I have both ESCs hooked up for both of the linear actuators, and then on our 5th channel I have the servo hooked up for the blade 5 and 6 way tilt. And then last but not least, I have the driver module for those Injora lights. This is included in the kit with the set of lights that I spec'd out. I have that hooked to channel 6 on the receiver. So I've used up 6 channels here, 4 for the functions, 5th for the blade tilt, and then the 6th for the lights. And later on we'll be able to just plug our cab lights on and off of here. When we take our cab on and off, we'll talk about that later when we build the cab. Just a super brief overview. Again, like I said, not going to go into depth just because I realize your radio setup's going to vary, but the way I have mine set up and programmed is that I have forward and reverse on the left stick, and then side to side, of course, on the left stick also. So this is set up as a mix in my radio. You'll be able to see both my left track and right track are moving and in opposite directions, so you're going to need to set up a mix. Like if you have an i6, it's pretty simple to set up that track mix. You could potentially rely on the mix that's built into the speed controllers. I don't do that. I like to do it in the radio because it gives you more control, but it's certainly an option. You'd have these speed controllers I spec'd out are able to either operate independently as 2 completely separate ESCs, or they are able to operate in a crawler or a tank type mode with the 2 channels mixed. So that might be something you want to explore as well. While we're talking about that, a note about those speed controllers that can throw you off. Make sure if you intend to use them independently like I have here, that when you power them up, the lights are red and blue on the ESC. Hopefully you can see that. If you've got, like, I think it's yellow and green, then it's operating in tank mode, or that mixed mode. There is a little tiny white micro switch on the end of the ESC that you can flip one way or the other. It is difficult to move that switch with the heat shrink the way they have it shrunk down, and so you may have to take take your little cutters and cut that heat shrink a little bit to be able to manipulate that switch, but that's definitely something to watch for because it can throw you off if you have the speed controller mixing things when you don't intend it to. It can be super confusing for a minute. Ask me how I know that. And then I've got the blade set up on my right stick, on the X and Y of my right stick, so I like blade up and down. I like blade side to side, so you can see when I go to the right, this cylinder is going to extend, which is in turn going to tilt the blade to the right, and then when I withdraw it, it's going to tilt the blade back to the left. Again, you may set those controls up a different way. This remote's pretty nice, and it has these sliders on the front, and so I'm able to use, and it has a nice center detent. I'm able to use that for my servo that's going to do the roll of the blade. On an i6, I imagine you'd put this up above, maybe on one of the rollers. The tricky part there is that I think those rollers are self-centering, so with a lesser radio it could be a little bit tricky to get this on a nice variable function, but you might put it, if you've got a pot, you might put it on a potentiometer where you can turn it and get it set where you want. So depending on your radio, obviously that's going to vary. I'll let you determine how you're going to set that all up. This just gives you an idea of how I did it and the 6 channels that are used, and then I've got a switch for the lights that will activate this module so you can turn the lights on and off. It would also obviously be perfectly fine to just wire those lights up directly, as long as you make sure you're supplying them with the right voltage user resistor, and just hardwire your lights so that you don't have them on a switch where you turn them on and off. But as long as your receiver has a 6th channel, which this little Free Sky receiver has a 6th channel on the back of it, so I've got the lights hooked up to that, so he'll have the ability to turn his lights on and off. Okay, I think that's enough about the electronics. We've got it to the point where all of our functions are correct. Forward is forward, reverse is reverse, left is left, right is right. We've got our blade working like we want it. We can go ahead and attach the blade at this point. I think we'll do that step next, and we'll get some tracks thrown on it. I've got some yellow tracks I'm building for this that are just about done, so I'll get those finished up off camera. We'll throw some yellow tracks on it, get the blade attached, which is really pretty straightforward at this point, and then we're getting close. It's really just a matter of finishing up the hood and the cab. So here shortly, we'll be able to drive this girl around on the bench and see how she works. Let's move on to the blade next. Okay, here we go. A bulldozer is not a bulldozer without a blade, so we better get a blade on here. I won't be able to call this a bulldozer. Pretty straightforward, really. Just a few items needed. We do need all 3 hex drivers: the 1.5, the 2, the 2.5. You'll probably want some tweezers. We're going to talk about these bushings in a little bit. They are in the parts list, but I'm going to show you it's entirely possible to build it without them, but you might want to get them. We'd use one of them through the actuator here. I'm going to show you it's really not necessary, but I wanted to spec them out just in case, since I have a 3mm bolt going through a 4mm hole. You'll kind of see how we mitigate that. So we'll talk about those later. I'm not actually going to use them, but I will touch on that later. We're going to need one of our drive shaft set screws. We're going to need a 4mm by 16 bolt. Now, it is entirely possible to use one of the screws that came with your actuators for this step. I don't, because it's silver and it has a Phillips head, which I don't like. I'm going to use this 4mm button head screw because I have a whole assortment of them. But if you don't have a 4mm assortment, it probably doesn't make sense to buy one just to get one bolt. So know that you can use the bolt that you've already paid for that came with your actuator. Again, 4 by 16. We'll need 4 of these 3mm by 16 button-headed cap screws. We'll need one 3mm nut, one 3mm washer, and then for our little upper control link here, we need a 3 by 8 and a 3 by 12. We'll need to build this linkage. In order to build this linkage, you'll need 2 of the specified Heim joints that are in the bill of materials, and you'll need 1 piece of 4mm threaded rod, or you could take a long 4mm bolt and cut it off. So in In this case, it's 4 millimeters by 45 millimeters is what worked for me. So I have a 45 millimeter piece of threaded rod in here. And ultimately, we're looking for an eye-to-eye length. This is going to be a little approximate because these are turned sideways, but about 66 millimeters is going to be the measurement that we want. Again, there's some tolerance there. As I mentioned earlier, we have more actuator movement than we need, more than the blade can physically move. So if you've got your actuator centered, again, we made this mark earlier a couple steps ago, you've got your actuator parked centered, that 66 millimeters should get you very close, but you might have to take this on and off a couple times, loosen up a jam nut, back and forth a couple times until you get the blade sitting as close to straight as you can when your actuator's centered. That way we'll make sure that we don't have any kind of conflicts, and then we've just got a couple 4 millimeter nuts on there serving as jam nuts. As far as the blade, I have gone ahead and glued on the laser cut steel piece here off camera. Put a liberal coating of super glue, sand the back side of the steel first so it's got some nice mechanical tooth to it, and then go ahead and glue that on. If you're using the printed blade edge instead, that's fine. It actually has a little more detail in it. I added some round recesses where the kind of truss-headed bolts would be on the front of the blade segments, and then it's also divided up too. So if you do opt for the printed one, it will look slightly different, but very much same idea. Go ahead and glue that on. As far as prep work on our blade here, lots of reaming and tapping really. So these outer two get reamed on top, 3 millimeter. Everything gets tapped on the bottom, 3 millimeter, except for this one is just a little bit different, the one that's under my finger right now. That's the one that our little control link that handles our tilt is going to attach to. We don't want to open that up to 3 millimeter. That's the one that is going to have a 2 millimeter axle bolt. Not axle bolt, drive shaft bolt going through it, and that 2 millimeter is going to go through our little control link, and it's going to bottom out in the hole. So the top of everything is tapped M3 tapped everywhere. And then all of them except this one, you can ream through the top and tap the bottoms M3. That way you'll be able to put your M3 by 16 volts through to capture all of our rod ends. Those will go through these three, and then again our drive shaft set screw is gonna go through this one. And then on the bottom, I just tap at M4, and I just tap from the bottom and go all the way through so that both holes are tapped in sync. Again, I'm gonna set aside this silver screw. You will have that, but I don't like to use it. You could certainly paint this black, do Sharpie on the head, something like that. Also, blacken your shaft here, your 4 millimeter shaft, so that it looks a little bit better. On the real dozer, that wouldn't be there, obviously. It's just part of the model, so we try to hide it, make it disappear by making it black. So, one more piece to glue on here. Make sure you tap this hole before you do, or it could be a little tricky to get a tap in there. You could probably still do it, but it'd be a little tricky. We're just going to add a couple small dabs of super glue here to the sides of our GPS mount, and then we'll get that mount on. This would be a mount for GPS receiver on the real dozer, and just line it up so it's centered and square. Make sure everything's good. Top of it should be level with these other two pads. Everything should be level and ready. Okay, that's it. We're ready to build a blade here. Let's do it. I start with the M4 by 16, and you can actually start this ahead of time. For that matter, you could start all of them. You could start any of the screws at this point. There's a good little tip for you. Make sure your super glue is actually set up before you start manipulating things. We will move that along here with a little bit of my favorite accelerator so that this doesn't fall off again. Okay, that's now stuck on. So we'll start with the M4 bolt down through the middle, down through the heim joint. This is what's going to allow the blade to move in all 6 directions and will give us that coordinated movement. As you can see at this point, the blade can move all over the place. Let's grab a couple of M3x16s in our 2mm driver. Actually, I'm going to put this in first because it'll be a little bit simpler. I mentioned it before, but these two ends need to be at 90 degrees to one another. Get this started. And we'll drive it in. Should be going through that reamed hole on the top. We should grab our threads on the bottom. Let us tighten it up. Okay, we've got that. Next, take another M3x16, and I mentioned these bushings earlier. You can ream this out and put this little Delrin bushing in here, and then it will accommodate the 3mm screw. But what I've found in reality is that this end actually kind of buries itself in the nylon actuator and centers itself, and there's really no problems. It works fine. So you can use those bushings if you want. Like I said, I wanted to include them because it's probably the more correct solution, but I don't really find it necessary. Either put some Loctite on the end of your M3 screw here, or I'm going to use my favorite clear Loctite here and just put a little dab of super glue on the end of our thread. Use your tweezers to grab your M3 nut here, and we'll screw this all together. The washer that I just slipped on there just helps the nut from becoming not buried in the nylon housing of the actuator. Super glue's already starting to set up. I got to be a little quick here. We'll grab this with some needle nose pliers, tighten her down. So the idea in the end here is that we get this nice and secure, nice and tight. And like I said, that heim joint, it actually starts to sink into the nylon when you get it just the right amount of tight, and it will actually work just fine without that bushing. So use them if you want to, but just know that it's not entirely necessary. At this point, we'll start connecting our dummy cylinders. So again, more M3x16s here to accomplish this. We'll leave this side off for now just because it'll be a little easier. Our upper control link, this is what's going to take this from being a floppy mess to being something we can use. Again, M3x12, M3x8. The longer side with this raised boss is going to go on the blade arm, and the shorter side will connect to the top of our blade up here. Both of these we want to tighten down, but obviously we don't want to tighten them down too tight. That upper link needs to be able to move. So we want the head of the screw just touching our plastic part, so we still have some nice free movement. Make sure you take your time and get those just the right amount of tight. So you can see with those, we've got some nice back and forth. That's going to be controlled by our servo here, which we'll hook up momentarily. Get everything lined up with our little arm. I like to do the same thing with this axle set screw. Just a little dab of super glue on the threads here. You could use Loctite too, that would certainly work just fine. Maybe be slightly less permanent, but we'll insert that down through our arm and we'll get that screwed in. Sorry, I know my hands are in the way right now. Wipe any glue off that's on there. Okay, and now our servo will be controlling our tilt back and forth. Okay, and we'll put our last bolt through. One last M3x16. Okay, there you have it. At this point our blade is attached, it's held on. We're ready to test its movement. I'll do a little brief cut here. I'll get these tools out of the way and get the radio back on the bench and fire this up. And we'll test this and make sure we've got nice movement of the blade. Okay, here we go. Got the radio on the bench, got the dozer fired up. Everything's working fine. You can see we've got our blade elevation up and down. We've got our angle of our blade side to side. Again, the actuator will move more than the physical limits of the blade will allow. You'll kind of know when you get there. I'll do it here. We reach the end point and you can see it starts to kind of wind up the blade, so that's where you as a driver needs to just be paying attention. You probably don't need those super extreme blade angles anyhow. Something like this seems to work really nice. So it's got a little more travel of the actuator than the model can physically support. Just pay attention while you're driving it. These actuators are pretty sturdy, but just don't leave one stalled out forever. Obviously it's not good for it or the speed control, but should work just fine for you. And then we've got our roll here. We're able to roll our blade both directions. You might want to set up your endpoints, your servo limits. Tiny little 4.3 gram servo. You don't want to be exceeding its mechanical travel, so make sure that your linkage isn't hitting here before your endpoint is reached. So just be aware of that. And that's pretty much it. We've finished everything mechanical and electrical at this point, aside from a couple lights. So at this point it's going to be details. I'll finish building those yellow tracks I talked about. I'll get those installed, and then we'll focus on the hood and the cab, and that's it. We're getting close to working model. Once we get some tracks on it, it's ready to drive here. She's ready to go, as you can see, and we will be moving dirt in no time. Okay, we are getting very close to the end here. We're down to the last couple steps. We're going to get the cab and the hood together, get a couple detail parts on, and then our dozer will be ready to go. As you can probably see here off camera, I finished up the set of yellow tracks I've been building for this dozer. Previously you saw me messing around with some older version rusty tracks. These are the yellow ones that were meant for this dozer, so I've got those completed and installed. She's ready to go. So we're going to finish up the cab and the hood, and then really we'll be done. At this point it's fully functional. Now it's just time to take care of some cosmetics. Not many tools required for this step. We're going to need a 2mm driver. We'll need some glue. I like, again, to have a small container. We're going to dip the magnets in a blob of glue that's on there, and that just makes it a little bit easier. And then off camera I've reamed the holes I'm about to talk about, so we definitely use the drill and reamer as well. As far as parts, we need the grill, the grab handles, the exhaust stack, the rooftop mounted GPS units, the rooftop mounted HVAC unit, obviously the hood and the cab, and then the front visor. Off camera I've done a little bit of work to the cab, so I've installed the laser cut windows. Let's talk about windows real quickly. You've got a couple different options, or three options really. You could do nothing. You could just use the printed cab with no windows installed. You could 3D print the windows. I'll include STLs for those, so you could print them nice and flat on a smooth bed and end up with a decent finish on them. Or what I think looks the best is to use this 16th inch thick laser cut acrylic. See, I've peeled the masking off of this one. The rest of them I've left the masking on until I'm kind of done messing around with it here, and then I'll peel the masking off at the very end. And I'm actually shipping this one across country when I'm done with it, so I might even just leave the plastic on, honestly, and let the recipient peel it off. I have also off camera separated two of the lights from the spec'd out Injora set. You have to cut them because there's not room to run the wires without. So I've cut two lights off of that harness of 4. I've set the other 2 aside. They'll be extras for another project. And I've soldered my 2 positives to the positive lead and 2 negatives together to the negative, and we'll plug that into our pins on the dozer when we're all done here. The other thing I have done off camera is to glue 4 magnets in. Now the orientation of these 4 isn't that critical because they're just sticking to metal. But with all the magnets, I had mentioned earlier that we'd want to pay particular attention to the magnets up here on the grill. So the technique that I use is that I stack my magnets up on the grill or whatever it's going to attach to, and that I mark the tops of all of them black with Sharpie. So these have all got black Sharpie on them. And that way, as I install them, I know if I see black, I have problems. I should be seeing the silver magnet. So just like you could see with these, silver magnet is showing. We're going to install them in the grill and the hood now. Again, I did the cab off camera just while I was getting the cab ready, but I think you get the idea there. I have reamed these holes, the two that are going to receive the magnets, as well as these 4 with the 3mm reamer. And when you do that, it's really just a matter of taking your magnets. Again, let's observe the black. I dip it in a little bit of super glue, and they should, don't break your grill like I just did. Now I'm gonna have to glue that. They should slide right in, and then maybe have something to press them against so that you can give them a little push, edge of your workbench or something. Again, we don't see the black, so that's a good sign. If we don't see the black, then we know we're in good shape. Again, don't do what I did and crack your grill like a big old meat-handed maniac there. And let's get the 4 in the body here as well, in the hood. So if you just slide them part way in and then kind of slide your magnets across, it will give you the chance to get the rest of the stack of the magnets out of the way and give you enough time to get those pushed in. You want them to be flush. Obviously, if they're sticking out, that's going to cause us problems down the road. I should have done these first when I had a taller stack of magnets. There we go. And for this very last one, I'm actually going to use the Allen driver, and I'm going to get us down to just 1 magnet here. Again, silver on the driver, black on the bottom side. And if we do this, it'll give us a nice little tool that we can push this down in the hole with. I went too far, so I will push it back out. We want these as close to flush as possible because obviously the strength of the magnet is gonna be decreased if you've got it a long ways away. So that should now fit nicely on our body, should stick down. Okay, we're good there. Let's glue the grill on. This little crack that I just created is actually going to be resolved in this step here. We will add some glue along the outside here. There is there's a ridge or an edge that's going to indicate or locate this on our hood. So we'll add some glue there. Slide this up and install it in our hood. Again, in my case here, I've got to really make sure that that extra leg is out to the side since I cracked it. Okay, and then I'm just going to shoot a little accelerator in there, tiny little amount. Doesn't take much, obviously. And we'll get this side. Shoot a little accelerator in there. Okay, now we've got a grill glued to a hood, and it should stick down if I haven't messed anything up. Okay, that sits down. All of our magnets made up. You could tell it's not repelling them because it would obviously not stick if we had got these 2 magnets in the grill wrong. Next, we'll attach the exhaust stack. 3 bolts in this whole process, M3x8 button heads here. We'll get one of these ready on our driver. I have drilled and tapped or reamed and tapped this for the M3 on the bottom here. You could put glue on your exhaust stack. I don't, because I feel like the exhaust stack is something that if anything was going to break, I feel like it would be the exhaust stack or the grab handles. And so I don't glue this exhaust stack. I figure why create the hassle down the road if you don't have to. So for that reason, I think just a bolt is sufficient. That way, if you bump this when you're at a show someday and you snap it off, you can obviously replace it, print a new one and replace it. The grab handles are pretty straightforward. They go on here with the long ones up top. and the short ones down here, there are little holes that they go in, so you would dip your grab handle and you'd glue it on. I'm not going to, because again, I'm shipping this one across the country, and I feel like those are just going to be asking for disaster if I do that. I'll show you on my finished gray hood here how those should look. These have been glued on, so again, you've got the two long ones in the top and the two short ones along the sides. You can also, alternatively, you can bend brass wire if you want to. Take some 2mm brass wire and use these as a pattern and bend yourself up some brass grab handles and then paint those black, nice and sturdy that way. So you'll have to just use your imagination, pretend like we've attached the grab handles here, even though I'm not going to. Let's bring the cab back over and the few detail parts that go on it. Let's attach this rooftop mounted sensor array here. We'll put a couple of bolts up through the bottom. I have already glued in the GPS receivers, and then I've drilled and reamed these holes on the bottom. That M10 bolt should just stick through. You don't have a ton of room here, or a ton of meat to grab, but you've got some, about 3mm worth that will grab. You could use glue on this part if you wanted to, and just kind of use either use the screws as locating devices, or even just use this the holes and look through from the bottom if you wanted to just glue it on. But the screws are nice in that they will keep it straight. You don't have to worry about any kind of glue oozing out or any kind of leaks or anything like that. And we'll just get that tightened down. Okay, we've got our rooftop unit on. This back unit, this HVAC unit, I did include holes, and there are holes through the cab. If you want to insert two of your own 3mm LEDs back here and use them as lights, you can. Some of these have lights in the real world, as I looked at pictures on the auction site. Some don't have the rear lights, they just have the cutout or the housing for it, but they don't all have lights. And so I didn't spec them out. If you want to get two white 3mm LEDs, either pre-wired or wire up your own with some resistors, keep in mind this output through this Enjora control box is only receiver voltage, so you're going to have 5 volts there, so you'd want to choose your resistors accordingly. The pre-wired 12 volters probably aren't going to work. The resistor value is going to be too high, so you'd want to pick the right resistor for 5 volts. We're just going to glue this on. A little bit of our super glue underneath. It kind of touches everywhere under here, and I actually see just a little bit of leftover junk from my supports. I'm going to clean up here just so that it sits down nice and flat on our roof. Again, don't get your glue too close to the edge, because if you do, obviously it's going to ooze out. You're going to have a shiny spot. We don't want that. I'll get this on there. And hopefully it'll sit long enough that it doesn't fall off while I'm putting on this front sun visor. The lights in the front, get them positioned kind of close here. Get them more or less where you want them, but have them down just a little bit. We'll glue this front visor on. Let's get it nice and centered. I'm going to be real careful to look from above here. I stand up for this step. I want to get this nice and straight. Obviously, if you put it on cockeyed, it's going to look silly later on. So let's get this on nice and straight. A couple dabs of glue here on the bottom side. And slide this on. Again, let's square this up and get it nice and straight before the glue sets up. Okay, at this point we can pull these wires from the inside, get our lights nice and tucked back in here. We're going to glue these to the visor, and again we want them to be kind of straight as well. We don't want that angled. Here's one of the problems with trying to do things quickly and in rapid succession without pausing to let glue set up. You end up popping things off. I did forget that I think just a little bit of this M3 logo shows, so I take Sharpie and black that out so we don't have any silly white lettering showing if you happen to have just a little bit of your housing stick out the front. We don't want that white M3 showing up. We'll hide that. Okay, let's see if we can successfully glue a light on here without any issues. We'll fold this down. You use a tool to pull it down a little bit. Add a dab of glue to the back of it. Get that brought up. Nice and straight. I think here's a spot when some accelerator is definitely going to come in handy. Try to keep this accelerator away from the clear acrylic windows, because the windows we've put on, I can't be certain that it isn't going to react with those and cause them to craze or crack. Acrylic's kind of a goofy plastic. It's affected by a lot of things. It doesn't love anything that has solvents in it, that's for sure. Okay, a little dab of glue under that one. Okay, that should be set. Again, you would peel the protective film off of your acrylic once you're done handling it and done working with it. I have, in fact, managed to knock the HVAC unit off. That just figures. Let's put a little more glue on this. Let's get him attached again. Alright, and this time I'm going to let that actually sit. When we come back, I will show you just a real brief overview of everything fit together, everything moving. We'll get the hood on there, we'll get the cab on there, we'll hook the lights up, and we'll watch her move a little bit, and then it's time for you to get your model in the dirt. Okay, we're back. Our model is done. Hopefully at this point you'll be able to determine if this is a model that you want to try to take on, if it's something that you like the looks of and the way it goes together or not. Again, there won't be any written instructions. I know I really said that at the beginning of the video, but this video will be your guide. This will be the extent of the instructions you receive, so you need to decide if you're comfortable with taking on this project with just a video as a guide, or if you're the kind of person that needs one of those super nice 100-page manuals. If so, I understand, no problem. There's some other builders out there with great models with really detailed instructions, but hopefully by the end of this you're comfortable with how things go together, you know what's what, and are ready to take on the project, and if so, that's great. Let's look at it real quick in its final form here, and then I just want to have a couple closing notes, sort of an addendum of sorts, if you will. I did alter a couple of parts, just slightly, things that I encountered during this build. This was the third one I've built, and again, there were just a couple little tiny tweaks and refinements that I made, and so we'll talk about those parts here briefly. But as you can see, we've got her fully functional. We've got our blade that moves in all 6 directions, or all 6 ways. We're ready to go take on some dirt, and bench top's probably not the best place to drive it, but we'll cruise it around a little bit here. Again, mine is set up with the differential steering. I think that's how most people set up a model now, so hopefully that's what you will choose to do. I've left the plastic on since, as I mentioned before, this is getting shipped across the country, and then of course I left those handrails off, and I'm actually going to remove the exhaust stack before I send it across the across half of the United States here and have UPS do their thing with it. We'll set this aside for now. I just want to show you a couple of minor changes I made. I had mentioned that there would be STL files for the window inserts. So here they are. This one's not particularly smooth, but you get the idea. If you wanted to print those smooth, maybe sand them, paint them glossy black. If you don't have access to a laser or laser cutting service, those could be a good way to end up with some windows. Another minor change I made is that this support for the grill, this base for this grill, now has a slot in it for the servo wire. So before, when I built this one, it was necessary to actually take the end off the servo to remove the little DuPont plug off the end and to feed the wires through the hole individually. Now I've made a slot, so you'll be able to slip your wires right down through there. So that is one change, and the slot goes towards the bottom, so everything will still be captured. You'll just put your wires through it and then put your screws from below to bolt that. So that's a minor change. You will have seen in the video, no doubt, that I encountered some problems with getting the 6mm shaft through here. I've now opened this hole up to just a little over 7mm, so you won't have any problems with getting that shaft through. It won't be necessary to ream it, so I fixed that. And then the other big change I made is that I realized some people have larger electronics, maybe a little bit larger than I used. I used a pretty small, discreet little receiver. Let's talk about the lights real quick. Just unplug them each time you take the cab off. Negative towards the front, positive towards the back. It's marked on the light module here. Back to this tray. There'll be two versions available. So the version that you saw me build the model with is shorter. It ends right here. It's just straight across the front. On this version, I took advantage of a little bit more room in the cab, and I've just added some more room. That way, if you've got a big receiver, you can see I put a little tiny Free Sky receiver in here, a little tiny 6-channel, discreet little thing. But if you've got a bigger radio, bigger receiver, maybe you're using a big 10-channel Fly Sky receiver, something like that, there'll just be a lot more room to lay it in here. So print either one will work, but just know that there is a bigger version available if you need just a little bit more room for your electronics. All right, well, we'll turn her off, and that's it. Again, I thank you for following along. I know it's probably been a pretty long video. I appreciate you sticking in there till the end, and again, appreciate you considering giving the little D1 a build. Thanks for your time.